Hey guys, good morning. Happy Teachers Day. Is it 5th? It's 4th of September. I think it's tomorrow, right? But yeah, it is in advance. Then thank you. Good morning, everyone. So we'll wait for next 5-10 minutes. Let other people join as well, and then we will start. Thank you, guys. Thank you so much. Thank you. You too, Anil. Thank you, guys. Thanks for your lovely wishes for the Teachers Day. Means a lot. Thank you so much, Chirag, Aditya, Shok, Ronak, Shubham, Ajinkya. Thank you. Good morning, Prince. Thanks, Archana. Good morning, Arav. Good morning, Sid. Thank you. And I hope whatever we talked yesterday after the class, you would have revised it. And still any doubts, anything pending related to that. So we will be having a doubt session for sure today as well, right after our 3 hours of technical implementation. So feel free to ask your doubts, ask your queries, whatever you have in the next those 2-3 hours. And today basically we will be focusing more on the practical side, right? We will be implementing the things, running and executing the queries. So for that, whosoever is joining, as of now, you can make yourself ready. Make sure your FileZilla is up, and so that you can transfer some dummy files from your local system to the Cloudera VM, right? And also make sure in your Cloudera VM, when you will open the terminal, you can type Hive, simple Hive on the terminal, and just hit the enter button. Your Hive shell will start executing. Okay, so make sure you are ready with that. Thank you so much, guys, for this lovely wishes for the Teachers Day. Thank you so much. So the technical implementation also basically you can say will be divided in two parts. So first part of technical implementation we will cover today, and next one we will cover the next Saturday. The next Saturday one will be very important from the Hive perspective, because we will be dealing with some pretty amazing and advanced concepts like partitioning, bucketing, and the joins optimizations. But today we will, or basically I will talk about the entire basics of the Hive and the HQL, how to write the queries, load the data, right, and different formats. All these things we will be looking at. All right, so let's wait 6 more minutes. By 10:10 we will start. And today, India-Pakistan match as well. Pretty much excited. What do you think? What will happen today? Who will win? I know the answer, but still. Yes, 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 yes. And who will be the top scorer from India side? Virat. Oh, nice. Nice, nice. Rohit, Sky. I'm pretty much confident for KL Rahul. Not sure. I'm getting that vibe that KL Rahul uh, will do big this time. Don't worry, I'll show you that how to open Hive. So I will be today, basically, I will be working on that lab environment, right, which you guys will be getting in couple of days, probably by next week. So just try to manage with the Cloudera VM for that moment. But still, whatever we will be doing on the lab environment, same thing has already been set up in your, what do you say, the Cloudera VM and all. So there won't be any issue. I'm pretty sure. I'll guide you that like I'll guide. सर जितना तैयार हो के कैसे आए हो थैंक यू thanks Devi Krishna, thank you so much. Good morning. Yes, yes. So whosoever is joining, yeah, by 10, like next 3 minutes, we will start. And I want you guys to be ready with your FileZilla and be ready with your Cloudera VM machine as well, right? Spin it up if you haven't started it yet. And I'll guide you after that, how to work on it. And whatever dummy files I will be creating and whatever we say queries I will be writing, right? So I will be copy pasting in the GitHub repo, and in the chat box, I will share the GitHub repo link. So once I'm done with the queries, and if you can type it along with me, that's pretty much good, right? But if not, so right, you can copy paste those queries. I'll be sharing it in the GitHub link as well, right? So I'll paste it in the chat box. So whatever is in terms of the queries, right? So don't worry. As I said, we will also have the doubt session today, right? After the practical implementation. Once we are done with that, so whatever queries you have, maybe related to today's class and the yesterday's, and even anything related to the curriculum which we have taught so far. So if you have any doubts and questions, feel free to ask to me, right? All right, so just 1 minute left and we will start after that. All right, so now it's 10:10 and I'm going to start now. Okay, so just a second. Where is my pen? Let me start. Do, 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 do. Just a second. Let me open the list of topic decided for today's agenda. All right. Cool. So let me share my screen and let me know once you guys are able to see my screen. Just a second. First, let me share the GitHub repo link as well. So whatever I'll be writing here, okay, let me put it in the chat box. Whatever, let's say, data I have created, dummy data or anything like that. So let me put it for everyone and keep this GitHub repo link with you, right? So I will put it there. And guys, and don't worry for anything. Let's say by anything which is related to VM machine, or you are not able to spin up anything. So probably just deal with it for this Sunday at least. And as I said, we are working on that part, right? We are working on the lab environment and it is almost done. So we are just working on the access part. So hopefully by next week, whatever class we will be doing, you just guys need to practice everything on that lab environment, right? You don't need to hustle with that the local Cloudera VM and all, right? So don't worry about that. Now let me start. So just keep this GitHub repo link with you, and meanwhile I will paste it 2-3 times in the chat box for the folks who will be joining right now, right? So okay. So okay. Let me know if my screen is visible. Is it visible? Yes, cool. Awesome. So right, in yesterday's class, we already talked about the basically why Hive is needed and what we will be actually doing with the Hive and all, right? So all these things we already discussed. Now it's the time to basically focus on the practical implementations. So pretty much simple. But before that, I would try to clarify a few concepts and then we'll quickly write the queries for the same hand to hand. Okay. So what will happen that in Hive, right? So it is again pretty much similar to the like the way we write queries in the SQL. So again, it's a data warehousing service, and it will have the like it will have the warehouse where the data will start, or where we will be storing the actual data, and I will talk about the source from where it can read the data. Along with that, uh, it works exactly like the databases. So here we will be creating databases. Here we will be creating tables. Tables will have column names, and it will have data types, right? And apart from that, we can load the data as well in it, and we can do a bulk load as well. We will have a concept of internal tables, external tables. So all these concepts will be there. So first let me give you a small overview that yesterday, right, to reiterate on that part. So yesterday we talked about, right, this will be our Hive engine. Okay. So Hive engine, here the way we are going to practice the queries. So let's say this will be our HDFS location, right? This will be our HDFS. So here some files will be stored. Let's say file F1 or anything like that is stored here, file F1. And this is our Hive engine. So first step, what we will be doing, In the first step, we will, let's say, create a simple database, right? In the second step, what we will be doing, we will be simply doing create table, right? And in the third step, what we will be doing, we will be loading the data from some source to the tables, right? Then simply there will be a load part, right? Load data in Hive table. Okay. So now I'll be writing few concepts that which you actually need to remember. So we talked about the creating table. So when we talk about the table part, right? And let me even before that. So since this is the Hive engine, yesterday I talked about two things. First thing was the meta store. Meta store was basically for the metadata, right? And second was the warehouse, right? So can you again quickly in the chat box let me know what is the meta store and what is the warehouse with respect to the Hive? I'm not asking like what this meta store will actually do, and what was the warehouse. We'll have the table details. Actual. Okay. Awesome. Awesome. All right. Yep. That's good. So yeah. So this meta store, yesterday we talked about, right, the Derby database or the MySQL or any external database which will hold the data to the metadata of the tables or the schema or anything which we have created. But as I simple say, right, I'll give you example of, let's say, MySQL databases, right? If I go here and let me type this one, MySQL engine, and most of the folks might have used MySQL or anything. So here what happened? So let's say you will be given access to a server where MySQL is simply installed, or you are programmatically accessing the MySQL. So simply again, what you do here, you create a DB. Okay, this will be the first step. Create a DB. In the second step, create table, right? Create table. In the third step, simple will be the load data. So all these simple steps happen here as well, right? So load data. So this MySQL, wherever it will store, so this will have, like, this will be installed on some machines, right? And these machines will have RAM, external memory, right? So wherever this MySQL will be installed, right, that will be also a separate instance, right? Will be on some, you can say, the servers and all, right? So whatever data, let's say, you are dumping, whatever let's say insert queries or whatever data you are writing, that will get stored in this table, right? In this table. So table, uh, eventually, like, we are writing insert command and it looks like data is getting stored in the table, but this is the physical data. So in the disk it will occupy some space. That means MySQL is just a framework or engine which is supporting these kind of commands, right, to manipulate the data. But under the hood, obviously this physical data needs to be stored somewhere in the memory locations. Okay, so this thing happens with the MySQL. So similarly, when we talk about the Hive, right, so meta store, any external database where you can say simply we are storing the metadata. But when we talk about the warehouse, so once you created a database, once you created a table, and after that, let's say you have loaded data in the Hive table, so that means it is eventually going into the warehouse location. So when you manually set up Hive, right, so there are few configuration files where you provide this detail that what will be the exact location of your warehouse. Okay, and I will show you all those paths, right, practically, that where it will be stored. I will run those Hadoop commands, HDFS commands, so that you can see those locations and the data itself. Okay, so here about this part, warehouse. So since Hive is something which has like built on top of it, so we can use the persistent storage like HDFS and sometimes even S3 as well, in order to consider it, or in order to use them as a warehouse, right, where our actual data is getting loaded, right? So I hope now this meaning meta store and warehouse is actually clear to you, and I will show all these things practically, so nothing to worry about that part. So now, since I have talked about this create table part and load table part, so quickly we'll be writing a few differences, right? So just a second. Okay, so first concept was the like you can say the table. So table, here there will be two types of table in Hive, you can say. First is the internal table, right, and second is the external tables. And internal tables sometimes also known as the managed tables, right? So this is one of the most important interview question as well, the internal tables and the external tables. Okay, so make sure that you prepare these things as well, right? Whatever I will talk about it, make sure you take a note of it so that you understand the difference clearly, and I will show all this thing practically as well, that how to create internal tables and external tables. So what will happen in the internal table, right? The metadata will be maintained by Hive, right? And another thing will be actual data will be stored in warehouse, will be stored in Hive warehouse, right? So this is the definition of the internal tables. So internal or managed, this is the main meaning of internal or managed, because completely they are getting managed by the Hive engine itself. Its metadata will be maintained, like the create table definition where it is stored, and all these metadata related information will be managed by Hive, and whatever data we will be dumping, that will actually go in the Hive warehouse itself. Okay, so this is about the internal table, and now I will talk about the external table, and after that I will talk about the advantages as well, right? So external tables are pretty simple to understand, like only for this one, metadata will be maintained by metadata will be maintained by Hive, right? And the another part is, let me simply put it this way, and another part is for this one, metadata will be maintained by Hive, and the actual data will be at source location. That means when we are creating external tables in Hive, so we are not bringing, or we are not dumping the data from the source to the Hive warehouse, right? So if I take a simple example, here this is the file F1 in HDFS. This is our Hive engine, right? And this is the warehouse, right? Hive warehouse where actual data will be dumped, right? So let's say this F1 is stored. So when we talk about the internal tables, right, And let me just draw this meta store as well, right? So this is our let's say meta store, right? So what will happen in case of the internal tables, this F1, right? First we will create the table. That means that means the metadata will be created here, and after that we will run a load command, which will simply loading command means here, from here what we are doing, load internal table, right? Load internal table. So whatever table we have created, F1 will go into the internal table, and this one, this data will go into the warehouse itself, right? In the structure format whatever we have created, right? So that's how the internal tables will be working. So internal tables, if I can write the steps, what will happen? Internal table sequence will be HDFS, right? Then load in Hive, then dump in warehouse. Correct. Now talking about the external tables. So in external tables, what will happen? Obviously, metadata will get created for sure for the external tables as well. But we are not dumping this data, right? This F1 data from the HDFS location to the table we have created. We are simply pointing while even creating the table, while even writing the create table statement, just point to source data in external table. So in the external table creation, what is happening? The data is something which is actually in the HDFS itself, right? And on top of that, we have just applied our schema. So in that case, only metadata will get created in this part, but the actual data is residing on the source location, and our table definition is pointing to that one. And since we have written some schema, so that will be validated while read time itself. So in the external tables, what is happening? We are not moving the data into the warehouse, right? So I hope the internal and external table definition part is clear. If yes, then let me know. Okay, if anything is not clear, right, when I will write the queries, you will get the idea how this internal and external table is part working. Okay, looks like external table is still a little bit confusing, right? Okay, let me repeat it again, no worries. Okay, so maybe when I'll write something on the screen, right, I'll create the internal, let me first write let me do it in this way, right? Let me explain two concepts more about the load part. Okay, and then I will quickly create one internal table and one external table on the Hive console itself, and from there it will be much more clear to you, right? I will show you, so don't worry about that part. And even after that some doubts are there, then I will clarify it, right? So the table, two types of tables, I think now we have discussed the internal tables and external tables. Once we will see all those things practically on the screen, after that, we will talk about the advantages of internal tables and external tables. Okay. But before that, we talked about the load part, right? How to load data in Hive. So even load part actually work in two ways in the Hive, right? So first, you can say load from local, right? Or second is load from HDFS, right? And here, see, across this Hive part, we will be talking about the HDFS as a warehouse and HDFS uh, as a source for the Hive as well. And moving forward, when you will be working on few things there, you will feel that other persistent storages can also be used in order to read the data. Like best example is AWS S3. But here, make yourself clear in that part that distributed data or the source data is stored in the HDFS location. Hive will be reading data from there, and whatever data is getting computed or table we have created, the data which will be actually stored in the table will also get dumped into the warehouse, which is in this case is HDFS itself, right? So there are two ways to load data as well in the Hive. Load from local. What is local and this thing, right? So let's say this was the server, right? Or basically you can say Hadoop cluster. Okay. So in the Hadoop cluster, right, we know there are two things. So when you log in onto the server, right, when you would have used that VM environment. So when you log in onto the Hadoop cluster, right, there will be a terminal open, right, where you are the current user. Okay, and there will be a so if you do a pwd, you run up that pwd command on the console, right, you will get your name as a current user or the user which you have used in order to create that account, right? So you will see there. So whatever is this machine where you have logged in, this machine, user machine or a client machine, you can say user or client machine or any sort of server, what you can say. So if you are or let's say you are having data file in it, okay, in this case what will happen data file in local machine itself. So if this is the case, then we can also write a command to load data from local path location to the main Hive table, right? We can load the data. But let's say file is something which is stored in the HDFS. So in that case, what will be happening? We have other load command as well, which will read files from the HDFS and will dump into the data file in HDFS. Okay, so this is like the machine where you made the connection or you did a SSH, and from there you can even execute execute the Hadoop FS commands, right, in order to copy data into the HDFS location. And let's say you haven't copied that data to HDFS and you are putting it in your local. That means the data is residing in your local, and you can also load it into the Hive table, right? So now let me quickly move on to the terminal part, right? And there I will show you that how to create the databases, and after that we will be working on this part, right? How this internal and external table actually works. So let me share my screen again, and let me know once it is visible to you all. Yeah, let me send the GitHub link again. So I'll be writing the scripts there, and you guys you can see my latest commit. So I hope the screen is visible to all. All right, cool. So so here, like, consider this one. So you will be having the simple VM environment, right? So here I will give you a flavor of both, right? How to even do things from the Hue, and also what I would say, like how to even operate on the Linux terminal and console. Okay. So here, what is going to happen? First, I will start the Hive shell, and from there, I will start creating the tables. Okay, and after that, I will paste the data for you. Okay, to get more information about it. Okay, so just a second. So I was talking about, if you want to understand that what is the local machine, or what I am talking about in terms of the user and client machine. So this is the server, right? Or the host machine where I have logged in now. So if I do a simple pwd, so this is the current user, right? I'm the current user for this machine. And whatever like I have yesterday I was creating some dummy data as well, right? So whatever kind of files I will be creating, let's say I did some vim, I opened the vim terminal and typed some text or something, or any file which I copy here or I locate here, that means this file is in the local system. But when I start using, let's say, Hadoop fs-ls and Hadoop fs-put command to move data from local machine to HDFS, that means data will be copied there. Okay, so first that's how you can start, right? In your VM machine, Cloudera VM, when you will open the console, you can simply type Hive, right? And after that, your Hive shell will be started. So yesterday, if you remember, I was talking about the 3-4 ways to interact with the Hive engine. So this is the CLI part, right? So here CLI means command line interface, where you can simply just this, like in the Linux box sort of environment, you will see this thing, and you can start writing things, and it will start getting executed on Hive. Similarly, there will be Hue as well. Hue will be a web interface from where you can interact with the files, right? So first, the first command is very simple. We will start by creating our database. First, we need our database. So the command is simple: create database, and we will give a name, Hive class batch 1, right? So this is the database we have created, right? So you can see, okay, it has been created. So now after that, once let's say we have created a database, and by any chance, let's say you already created a database and it is already present in your Hive, so what you can do, you can simply use that database, or you actually need to go into that database. So for that, what command we will be using? Simple use and the database name. Okay, so that is how the database, first you created a like fresh database, and since within this database you want to create few tables, so for that, what you need to do, you need to go inside that database, and that is why we have used this command, use this particular DB name. So now whatever operations we will be doing, that means we are doing it inside this table, sorry, we are doing it inside this database. So this part is clear. Let me quickly paste it in the Git, right? Hive class 2. Okay, and let me paste this thing and this command, right, quickly. Okay. So let me know if you guys are able to see this thing, new file in the Git repo. Are you guys able to access it? You found that those commands? Okay, and try to execute it as well, right? So that's what I'm saying. In parallel, if you have opened your VM box, simply try to execute it. Awesome, executed. So database has been created. Now, what we are going to do, we will be creating a table, right? So again, as I said, these commands are pretty much simple. Again, very much similar to the SQL. So we can do multiple operations. The way we have created a database, we can drop a database as well, right? And after, let's say, when we have created a table, we can even alter the table, like renaming the column name, renaming the data type, and all these things, right? And within that, let's say if we want to see how many tables have been already created, right, within a database, so we have a command for that one as well. And let's say we have created a table and now we want to see that how its structure will look like. So we have a command for all those things as well, right? So let me simply open it and I will tell you that how to create it. So first I'm going to create a table, and for that I have already, let me first push the data here for you all. uh, okay, let's me do it simply. New file, upload file, right? So so this is the department data.csv. This is the one file, data file I have uploaded, right? And let me commit it. Hope you guys will be able to see it quickly. So department, I'll show this data as well, how it will look like. So it will have actually 4 columns. First column is the employee ID. First column is the department ID. Second is the department name. And this third column is the manager ID. And fourth one is the salary, right? So that's how we are going to create this data, or we are going to use this data set, right? And we will be creating a table according to that. Okay, so this is the data set. We have the department name, the integer type for the department ID column, and then we have this manager IDs, and after that, this one we can treat as a this is the employee ID. This could be employee ID, and this is the manager ID. Let me just quickly check. Okay, so let me execute it. So we have 4 columns. Now I'm going to create a table. So the simple command is create table and department data. Okay, so department data, and after that we will give a name to it. So ID column, or we can say simple department ID as int. Okay, and after that department name int, and after that we can say like manager ID, right? That, sorry, department name will be a string. Sorry, my bad. Just a second, let me cool. So just a second, let me retype it. Create table department data, and then we have department ID as int, then department name as a string. This is the data type. So for any kind of string or where characters are there, right, or any kind of field which you want to use as a string, we can use the string data type. And then manager ID will be again int, and then we can last 4th column, let's say, was the salary and it is again int, right? So this is the simple columns and all these things we have created, and the data which I have shown you, right? So how we create the basically what the way we try to dump the data, right? So the data we are going to operate here is basically the CSV data. So here the columns are actually separated with the comma, and these rows, right, these are separated by a new line character. And there could be multiple scenarios where the rows are itself separated by any other characters like tab and all, but by default, even if we write this statement, right? So after creating the table, we need to write a statement which is basically row format, right? So row format is delimited. right? So default, it is basically the new line character. If it is something else, then let's say the tab or something, so we can simply put this delimiter as well, like which whatever delimiter is getting used in order to separate those two rows, right? But by default, since it's a CSV and it's a new line character, so row format delimited we have used. And after that, we need to we need to we need to provide this information as well while creating a table, that what is the separator, or what is the separator or delimiter which is getting used in order to separate two column data. And for that one, the command will be field delimited by, or field terminated by comma, right? And now if I run it, just a second, let me copy it again, and mistake, it will be fields. Let me copy it quickly. It's a typo. Simply do that. Fields. Rows format will be delimited, and it will be not field, it will be fields actually. So that's why it was a typo. Just a second. Fields terminated by comma, right? So here, let's say this, if I open the raw file, right? So here you can see, right, these files are actually, or the column values, let me zoom it little bit, right? So you can see these values, right? Individual values are separated by comma. So there are other, like when we talk about CSV or .tsv and these kind of files, so what will happen, there could be another separator which can be used, let's say pipe as well. So instead of comma, pipe can be used. So if those are the conditions, right, and you have that sort of database, oh sorry, that sort of data set, so fields terminated by this property is basically to let the Hive engine know that for this table, whatever data we will be loading, the column values will be separated by either comma or whatever delimiter we have provided, right? And for this one, row format delimited means by default, the rows are separated by the new line character, which is \n, right? So here now you can see table has been created. So if I simply do this part, right, show tables, right? So here we can see this department data table as a in list. We can see here, right, it has already been created. Now if we simply look at this part, right, what was the definition of this particular table, right, and let's say how its architecture looks like. So what we can do, simply we can run a describe command, right? So describe, basically what we want to see this part, like how its table definition look like. So describe simple this particular table name, right? So you can see the its schema part, like department ID, it's a type, and the department name, its type, manager ID, its type, and the salary which is like integer type. And after that, let's say you want to see much more information, this is because just the schema part, and you want to check and identify things related to the formats and all. So what you can do, you can use this describe command again, and you can add one more keyword here, which is the formatted. Formatted, right? So once you run this one, you will see a very elaborative detail here, right, including the column name, data type, right, and which database in this table is, who is the owner, right, and when it was created, where it has been actually stored, right? So this is the part which I wanted to make you understand, right? So this location, right, is something which will help you to understand. So HDFS, as I said, so first quick question, this is this table, right? This is an example of the internal table, or you can say the managed table. And this information you can see from here as well. Table type, managed, or we can say the internal table. So internal table, what means the metadata, and simply the now the data, whatever we will be storing, that will directly go into the warehouse. And this is the actual part, right, or directory which has been created where our data will get stored in the HDFS, because HDFS was something which we were using as a warehouse, right? So you can see all this information. It is a managed table, the parameters and the kind of Saturday input format, output format. I will talk about this one. This will be a another topic of discussion for the Saturday's class, where we will be talking more about the bucketing and all, right, sorting, partitioning, distributed clustering and all these things. But for the time being, you can ignore all these things, but focus at least on this part, because that's what I wanted to make you understand. So after first, let me paste these commands for you all, right, quickly, so that you can run it and you can check all these things at your own end, right? So this is the Hive class 2 txt. Within the same table, I am adding these commands. So this is just make sure you remove these greater than, like, these signs, right? And after that, I will paste this describe command. So far I haven't uploaded any data into it. I have just like created a table definition, right? So that you can get the idea that how it is actually working. Right now, let me quickly commit it. So this is clear, guys. Okay, so repeat. So commands I have already pasted. Please share the GitHub link. Let me share it again. I will give you the GitHub link in the chat box. Again, just a second. So this is the GitHub repo link, right? You can find, please, formatted explanation again. Can you do it? So we can do it, sir. We define table to be internal or external at the time of the, yes. So your question is correct, Shiva. So it will be decided on the time of creation itself, whether you want your table to be internal and external. So for that, once, so this is the by default, whatever table we will be creating, right, without any other keyword, that will be simply means that it is an internal table. When we will be creating an external table, we need to add one more extra keyword here, which is like create table, then external, and then the table definition. So that's how it will be distinguished during the creation time itself. Cool. So once I will explain all these things, right, then we will talk it about, right, which is better and why and what are the simple part, right? So don't worry about that. Okay, so one question here I can see, right, as you have mentioned, created data will go back to HDFS, which is data warehouse. Little confusing, right? So you don't need to get confused here, right? So what will actually happen? So the data we are, the data which, let me explain you for, let me explain it for you. So see what will happen. So far we are talking about the simple CSV files and all, right, where data will be looked or data will be in plain, let's say, what you say, format. Let's talk about the semi-structured data sets, right, or any formats or anything like that. So let's say your source data also can be in Parquet file, right? Your source data can be in simple JSON data as well, which is a semi structured data set, right? It will be something like this one, right? Let's say it will have keys, some value v1, then another right, another column name, and let's say then value v2, right? So this is one object within a JSON object. There will be another object, right? So this is a semi structured data for you. But whatever data we are trying to create, right? So simple, you need to understand the meaning of the data warehouse. That's why we are saying whatever we are creating in Hive, and even Hive is a warehousing service, right? So this data, right, which is in your source, it can be in different raw formats like Parquet, Avro, ORC, right? And Parquet, ORC are something which you cannot open in your terminal, or like Notepad plus plus, or you can read the data. CSV is something which is readable because it holds data in the simple objects form. But when we talk about these file formats, Parquet, ORC, Avro, they will be storing data in the serialized form and in the compressed form. You won't be able to read it, right? Those are not readable. And similarly, let's say JSON and XML data, these are the semi-structured data where schema and column names are quite flexible. You can keep on adding it and deleting it. Okay, so this is something, right, which is not a structured data. Structured data means in terms of the warehousing services, we always say that any data which is something in this format, right, rows and some sort of columns, that is somehow the structured data for you. So whatever we are storing in this part, right, let's say the warehouse of Hive, and the main purpose to use Hive here, right, basically to read raw data from some persistent storage, distributed storages, and just somehow give a feel of MySQL type of tables, or store data in the warehouses in the form of the structured data, so that that is something can be that can be executed on the Hive engine, just like the SQL tables, which are simply like the rows and columns. So this is the main purpose of Hive. And so I know this might be confusing, that HDFS is source here as well, right? Source, and HDFS is also working as a warehouse for Hive. So that is the reason, because even Hive is something which is meant for the big data computation. So whatever data is getting dumped into the Hive, so that is not a, let's say, just MBs of file. It will be also sometimes terabytes of data and 500 GBs of data. So wherever it will get stored in the backend, right, it also has to be the persistent storage. And since now you have understood the purpose of Hive, so the source HDFS, that data sort of can be anything, any raw format of the data. But what we are moving into the Hive, that will be stored in the warehouse and will have the structured data feelings, right? So I hope I have made you clear on that part. Cool. Yeah, this definitely, it will occupy again space, right? So when we talk about the internal tables, right, so whatever amount of data you stored in the source location, right, let's say it was 500 of GB data, it was a source HDFS, so 500 GB of space again will get occupied. So mostly how things will be done, right, most of the time it will be preferred that the external tables are being created if that is too much of the analytical processing, and we want to save the space. But if that is not the case, right, simply we can work on the like we can simply work on the internal tables, right? That would be simple to understand, that where to use the external tables and the internal tables. And there is a very major difference to understand. Probably it will be understood to you when I will show you the commands and other things. But at least tell me this part, you have understand the syntax of creating internal tables, how to check the information about the tables, that what is the simple part of it. And now I will show you that where all these things have been stored, and how to even load the data into it. When I will show you this part, like loading part, after that it will be much more clear to you. Okay, so this part is done, and we have created the internal table. Now let me show you this part, that what I will run the Hadoop HDFS part, right? For a time being, I'm just doing an exit from here, right? Now I wanted to show you this part where the warehouse which we are using along with Hive, so where this directory will be created. So in your local system, right, what you can simply do first, let's say you would have run this command, right, in your system, what you say, the Cloudera VM. So in the location you would have got the HDFS location. So simply from there you can start. So this starting part will be simply the user related, but the HDFS part will be something which will start from the root itself. So how I will find this location, Hadoop fs -ls. First I will go into the user / Hive, right, and let me do a ls here. So /user /Hive, I can see this warehouse directory, which was eventually created when Hive was getting set up here. As I said, when we do these configurations and setup, that time we need to provide this location where in the HDFS, the data warehouse will be created. So Hadoop FS, now let me do the ls in this part, right? So warehouse, since other folks were also practicing something, so for that one there will be lots of files. I don't want you to get confused, but let me simple type this sort of regex, right? So I know my database name within the warehouse, my DB name will start with like this, Hive class B1, and then something after that, right? So I will only get that location, right? Now this is the exact location and the department data table we have created. So how this naming pattern, you can even see how it is getting followed. So within the warehouse, the first directory will be created as a DB name, right? So DB name, and within that, what will be happening within that, there will be a table name, right? So table name, and now if I do a ls, we will try to see what is there. So this is something which is completely empty as of now, and completely empty because we haven't loaded anything into it, but we have seen that directories and everything has been created. So our internal table is ready, and I have already showed you whenever we will be working with the internal tables where our data will get stored in the warehouse. So that's how you can figure out the path and other things, right? So now let me start the Hive engine again, and now we will try to store the data. Okay, so for that one, since we talked about the two ways, first we will try to load the data which is stored in the local. For that, again, I need to take a exit. So local, now I will show you that since this is a server machine, right now this is the server machine, and I should treat it as my local machine. So whatever data is present here, and I haven't copied anything using Hadoop fs-put command to HDFS location, so that data will be treated as the local data. And here, like I have already created one folder, so cd data, and I will run the pwd command, so present working directory. So this is my directory, right? The whole path for this data folder, and within that I will show you that I have already copied this file. So how you can do it? You can do it with the help of your FileZilla. So the data set which I have provided to you, you can download this data, and let's say you are not able to do that. So very simple to do it. Let's say click on it and then go to this raw tab, click on the raw button. Okay. And then just do a simple control S, select this whole data, create a new file, right, in your system, let's say using Sublime Text or Notepad, paste this data, give a name to this file, depart underscore cs underscore data dot csv with the csv extension, and that's how the file at least will be created in your laptop. And after that you can use the FileZilla, right? From the FileZilla, wherever your Cloudera VM, right, in the local location, wherever you want to place it, you can do it, right? So let's say you have initiated your Cloudera VM machine and user is created like /home/Shashank. So within that you can create this data folder, run a command like to create a folder, right? In the Linux system, it is pretty much simple. So let's say I was into this location, right? And within this folder, I want to create one more folder. So let's say mkdir means make directory. And after that, I can give a, let's say, any folder name. So data, not data, let's say Hive class 2, right? So this directory has already been created. Now, if I do a ls, I can see this directory Hive, and I can see another directory Hive class. But my data is present in this data directory. So this file, which is present in this machine and within this local path, that means this is the local data, right? So now the option which I'm going to show you, that is something that is something which is the local data, right? And we will try to load this data into the Hive table. And now I will tell you one issue might many of you might encounter when you, let's say, work on the prod related servers, or even these kind of environments, right? Lab environments we are using. So sometimes things can be like related to the access issues. So in that case, you can use a generalized temp library, which will always be open for any, and it will not have any kind of restrictions in terms of the use and all, right? You won't get any kind of permission issues there. So let's say this data right now, this depart data CSV is residing in this particular folder, right? This one /home Sudhanshu and data. So many of you might encounter, let's say you copied your file to your home location, you might when you will be trying to load the data from this path, right? Let's say this and / my file name into the Hive table, you might encounter the permission related issues. So in that case, what you can do, simply you can use the root temp folder. So how you will get that root temp folder? So /ls/tmp, right? So you can see lots of things have already been created, right? Because we are working on it, right? So temp, let me search something like Hive. Yeah, so this is something which I created, right? Yesterday itself, this folder. So within this temp directory, so try to find it, right? Just simply run this from what you say, from your local, wherever you are at this moment. Just try to use this command ls/temp. / is basically, if it is not starting with anything, / is basically for root. So ls/temp. I'm not doing a ls. What I'm going to do, I'll do a simple cd. I have already created it, Hive class, right? Now I am into this directory, and if I do a ls, you can see this file here itself, right? So now the current location is temp / like within the root, there will be a folder temp, within that Hive class, and within that this file is being located. So that's how I have explained. If let's say for the first option, you are when we will be running that load command, if you find any difficulties, then you can use that a journal temp folder, right, of your local machine, because it won't give you any permission related issues. And then within that one, you can create one more directory and you can place that data there, right? So now from here, let me simply again start my Hive engine, and I will show you that how to load data in the internal Hive table. First, from the first we will try to load it from where? The local path. And another option, we will try to load data from the simply the HDFS path. Okay. So again, first we need to go into the database which we have created. So Hive class 2, this is the database we created. Sorry, what was the DB we created? I forgot, just a second. I think it was DB1, batch 1, sorry. Okay, so this database we already created, and we will simply use it. And if I do a show tables, we will see the table which we created, right? That is already present here. Now what we are going to do, we are trying to load the data from that local path which I have showed you. Okay, so for that one, let me write a command. So command, it's simple. Load data local. So load data is the starting keyword, and after that this keyword local, what it will tell the Hive engine that after this local keyword, whatever path I am going to mention or whatever file path I am going to mention, Hive engine should look for that file in the local machine itself. Don't go onto the HDFS path in order to find that file, right? So load data local, and in path means the input path. And after that, we need to mention the whole path for that local file, right? Or whole path for the file which is in our local. So the file or the location we have is this one, right? So /temp, and this is my data. And I will tell you one thing. So whenever we work with the local file systems, so we need to help Hive in order to parse those file path names successfully, because it will try to find the file name in the local system. So whenever you talk about the local systems and any other, so for an example, when we were looking at the HDFS path or anything, right? Let's say Hadoop is a file system. So how this whole path URI starts? URI means unique resource identifier. So it starts from HDFS, then colon, then /, then file name. Okay. And anybody, let's say, have worked with, let's say, AWS S3, that is also a file system. So there, how this URI for S3 starts, S3 colon // and so on. Now, since it is all about the local file system, so URI for local file system is also different. So what you need to do, you need to add this one, file colon // and after that this complete location. So in total there will be 3 // right? So this, now our Hive engine will be able to identify this location in our local machine, right? So this will be the correct path. After that, what we want to ingest this data into this, like, local data into table, and this is our table name. Table name is the department data. Right now, let me execute it. So here you can see loading data to table Hive class B1, and OK means without any error we have got this one. So now if we run a simple select star from this table name, right, we will get the output, right? So we can see this thing, right? The first column, second column, third column, right? Now, since this is the Hive, and you guys might be very interested to check, because we have already talked about that Hive is something which will convert things from map, reduce, right? Since this was a simple select star statement, there was like no need of doing that map task and the reduce task, because it is a simple data we are trying to look at from the samples, right? Now I will quickly show you that where you can see that map tasks are running and reduce tasks are running or not. So let's do a simple count star on this table. So count star from this table, right? And now you will see all those things, where and how this map and reduce are getting created, right? So here you can see, right, stage 1 map tasks have been created. So number of mappers 1 and number of reducers 1. So at this point map was completed 0%, reduce was completed 0%. In this statement, map task has been completed 100%. Here reduce had been completed 0%. But till this part, map also completed 100% and reduce also got completed 100%. And here we can see the total output, which is equivalent to 27 records. Get it? Guys, this part is understood. Again, I will paste this load command, right, for you. Don't worry, right? So can you tell me again that what is this part? Okay, tell me the confusion, right? Where you guys are a little bit confused. I will share all these command, not to worry, but where is the actual confusion? How to load the file? Okay. Yeah, I'm going pretty slow still. Copy to FileZilla. Mm-hmm. So one thing to call out, right? People who have joined the first time and not able to get that FileZilla part and the Cloudera VM part. So for those folks, I would recommend to watch those previous class recordings, because the day it is started, everything was like everything was created there, right? Everything was explained there, that how to set up the FileZilla, what is the use of it, the Cloudera VM part, how to work on it, and HDFS command and all those things, right? So don't worry about that part. So this download part, right, which I already explained it, right? I will explain the load command. Don't worry. So, and apart from that, let's say you are facing any technical issues, technical challenges, right? So after the class, you can definitely go to the support part, right? Where these folks will sit with you over the Zoom call and will technically fix all those challenges for you. Let's say your Cloudera and all those things are not working, right? So this part again, right? See, I have shared that GitHub repo link with you in the chat box. If it is not there, let me share it with you again. I can do it multiple times, not an issue, right? So if you go into this one, right, here in this folder, I have given you the link for direct folder part, right? So what is going to happen? You will see this depart data.csv, right? So let's say you don't see any what you can say, you don't see any option to download here, right? So see, this would have been easy for those folks who know Git, how to use Git and all these things, but that is completely fine. You can do it from here. Else, right, you can install Git in your system and you can copy this Git path or this Git CLI, and you can even download this zip whole folder right from here if the Git is installed, and you will see this file there. And time to time you can keep on taking the Git pull will give you all latest update which I'm committing here. Okay, but still, let's say you want to download it from here, you might not see the direct download option, so click on this file, right? And after that, what you can see here, after clicking on it, right, you can click on the raw part, right? And after that, you can simply copy it, paste it in any of your notepad plus plus or something, and you can pick it from there, right? So that's how you can do it. Now I will explain the load command again. So I know lots of people might also get confused for this part, the temp and all, right? So let me clarify one thing. So here, this was the, not this one, right? Let me show two things to you, right? So this is my local machine, this is my local server, right? Here, this is the directory. So let's say there is a one single Linux machine which is on the remote server, right? So multiple users can access it. So if you are one of them, then you will be allocated some username, and using that username or the login, right, you can log in onto that server. So when you will be doing that, you will directly go into your folder which was created under your username. So for me, this was the username, right, which got created on this particular machine, right? So this is my local directory, right? I am reside, or this is my local directory, right? This is my local directory where I am just residing in this particular box or this home directory which has been created for me, correct? So within that, whatever I will be doing, I can create multiple folders, I can store multiple files. That is my local machine. And apart from that, right, there is a generalized local environment, right? Let's say there is a machine, and for each machine there will be a root user, right? And there will be a temp directory always, right? Temp part, right, where right, you don't need those sort of accesses and you won't find any access related issues. So in that case, what will happen, as I said, right, what you need to do in your simple system. So first you can try with this part, right? I'm not saying directly you need, let's say in this load command, right? I will paste this one. Let me paste this load command for you all quickly. Where is my load command? Yes, let me paste it for you. Right, so this is the load command. So in this load command, right, what I am saying, this whatever file path I have written, so for me I was getting access related issues, so I didn't use this path because, as I said, here I have created one folder and within that my file is present, department data. And what is the complete path of this folder? This one, right? So when I used actually this one, right, I can simply what I can do, let's say, let me copy this command from here, and how it can be replaced, right? I will also show you. So let's say I stored this data. So instead of /temp, right, because I was using the roots temp directory in order to store my local data, that's why I was accessing it. But let's say my home path is actually working. So how it will look like, this thing, I could have used this part, or I could have named my file path in this way so that my Hive can pick data from this location. But for me, because this is the new lab environment which has been set up, so I was also getting few access related issues. Okay, so I didn't use this path. What I did, I used the roots temp directory, right? Simply understand this part, roots temp directory, and the path is not temp. So it will be always, right, let's say you are currently in your home directory, simple home, right? Whenever you will do the login, you will be landed into this location. Wherever you will be landed, just run a pw command, pwd present working directory, and you will get this path, right? And after that, what you can do, simply just let's say run this part, ls slash like ls space slash tmp, not temp, right? Again, watch it carefully, it is /tmp, right? And after that, if I run, like, I will see multiple directories because we are using it for our purpose, right? Sometimes whenever we face this kind of access related issues, right? So let's say you are trying, don't try to find, right, whatever I'm writing here, let's say, don't try to find it completely, that it will be created in your Cloudera VM, right? What I have created, this is a folder which I created for myself. So what you can do in this temp folder, right? Let's say just go into cd, do a cd/tmp. Now you are inside this tmp folder, you can see here as well. And within this temp folder, create your own new directory for storing this kind of practice data. So mkdir, let's say Hive, like I can create it like student Hive temp, right? So this is a new directory I have created. Cool. And now I can quickly go into this one, student Hive temp. Now I'll show you the pwd command. That means my present working directory is this /tmp/student Hive temp. So in my example, instead of this location, student Hive temp, I am putting this one because I created this folder Hive underscore class by myself within the temp folder. And now let's say from your FileZilla, you can directly you can directly open this first, like after creating this folder, right? If you refresh your FileZilla, you can get this location, right? /tmp/student_hive temp. So from your local laptop, MacBook or Windows machine or anything, so this data, right, which you created or which you downloaded, you can simply upload into this location, right? As simple as that. And for the Mac users, right, let's say if you are finding difficult like FileZilla and all these things, so in that case you can use the simple SSH command as well, right? So for you, your VM is in your local host, right? So you can just do a quick check over the internet that how to copy the data from the Mac terminal to the virtual box, right, inside running inside the MacBook, right? So that would be a simple command. But let's say whenever we talk about the production or company related setups or infrastructure, so you will be having a remote cluster and remote machines. They will give you the IP address for that, or the we call it as a host name and the user, right, which you can use in order to do a SSH, and you can use to do a login part, and then you will be able to do that. So I hope this temp part is something which is clear. Don't try to just get this one, right? So within the temp folder, you can first create your own directory, and within that directory, try to copy this file into that directory and then write your own custom file path. Is it understood now or still confused? All the commands are in Git. Yeah, so you are talking about explain this file path, right? So see, if let's say postman is coming to deliver something at your house, right? So if temp folder is not visible in FileZilla, you can first try to copy that file in your, let's say this temp folder is not visible, but I hope this folder will be visible to you, your current home path, right? Home path is, let's say, visible to you. So first copy path, and once you are created this, once you have created this part, right, this directory in the temp folder, you can use this cp command. So let's say the file has been copied into my local directory, right? Data, departed data. I can use this cp command to copy this data from my local VM machine to the temp location of VM, right? That means /tmp and then student hive temp, right? So this data, so let's say this temp folder was not able to, you are not able to get it in the FileZilla. So simply you will be able to see your home location. First copy file from your local laptop to this home location of VM, and then home location, from this home location of VM, copy this file to the temp one. Yeah, so anything, right? Home, Cloudera, that's why I'm saying, right, I'm talking about whatever is your home location. Since you are using the Cloudera VM, so your user will always, for everyone, this user will look like this home Cloudera. So you can simply copy file into home Cloudera, then you can run this command, right? cp/home/Cloudera and whatever, let's say depart.data.csv, and then in the temp, right, and student Hive, you can copy that particular data, right? That's how it will be done. Right now, talking about this part. So as I was saying, let's say the postman is coming to deliver something at your home. So he actually needs to know all that particular location and all these things. Okay. So what will happen in that case, right? So they should definitely know something, right? They should know that what is actually the location, or what is the home location, right? So for that they need an identifier. Let's say you are living in a locality, so there will be a specific tag will be given to your locality, and with the help of that tag, someone will able to find your home location. So similarly, different file formats have different tags to access it. So whenever we talk about the local file system means always your laptops, your desktop, or your machines, right? So in order to identify the local path of those type of machines, we need to use this file tag, or sometimes we mostly call it the URI identifier, right? So file colon this, let's say any file, right? Any file which is stored in the HDFS, right? I will tell you, any file, if you find it, let's say stored in the HDFS, the path will look like something this, right? You will always see this path, because HDFS is another type of file system. So every kind of file system will have its own unique identifier name, and based on that identifier name, any engine, any program will be able to figure out where it needs to find the file. Since I have given that identifier, right, file colon something, that means Hive engine was able to understand I don't need to go into the HDFS directory to download or to look at that file. I need to go into my local machine and local server in order to find that file. So this was the internal table part, right? So I think now this is more on the enough explanation part. I hope you guys have created it, all things I have simple right explained it in terms of so because we also need to move in little bit fast in order to cover all those things, right, in at least 2-3 classes, else right, we won't be able to cover things by the time, right? So try to grasp it quickly, because we will be having next 2 hours as well, right, for our doubt session. So we will be taking up all those things there, right? Not to worry. So your file has been created. So far we have understood the internal tables. I have shown you that path as well, right? Now before that, what was actually happening, right? So just let me show you that path, right? After that we will take a 5-10 minutes of break and we will resume again. So earlier, right, when I created that empty file, right, I showed you that the location and the directory has been created in the warehouse HDFS location, right? Now let's say if I do this part again, right? So let's try to, since now we have uploaded the data, let's try to look at what has been dumped into the HDFS location, correct? So for that we will run this command again. So you can also do this part. You can, for in the Hive terminal, first you can run this describe formatted and the table name command, and you will get the HDFS location for that particular table where the data is getting dumped into the warehouse. But since I already know in my system where it has been set up, so I will be directly going there. So Hadoop fs -ls, right? And after that /user /hive, right? And within that warehouse, and my DB name was Hive class b2.db, right? Oh, it was b1, sorry, right? So it was created. Right now we will go inside this table name. This was our table name, right? Now you can see this sort of data which we pulled from somewhere. You can see this has been come into the warehouse, right? So that's how this local data actually was created, right? Now this is why you can see this data into the HDFS location, because you didn't inserted this data in HDFS manually, right? You can see it in the warehouse when you ran this command. So that means whatever data we are dumping into the internal tables of Hive, that is actually getting transferred to the warehouse. Now when we will run commands for the external, when we will create the external tables, I will show you the clear difference that what is different between the internal and external tables. Fine. So let's have a what is the time? We have 11:34. We will meet 11:34. Let's meet at 11:40. Hello. Okay, are you guys back? So cool. So things are done for the internal tables, right? Now, two things are left. First thing, basically, so far in terms of the load, right? We have seen the how to load data from the local file. Now, I will tell you that, let's say, the data which we are trying to load from the local, right? Local file system to the Hive table. What will happen if our data is stored in the HDFS location? Right. So what will happen when our data is stored in this source HDFS, and how we can load the data from HDFS to the Hive, right? How it will be done, I will show you. And then we will be looking at the external tables, right? So sorry. So first, let's say what I wanted to show, there was someone who was saying how to see the column names, right? So just a second, let me show you that how you can see the column names. So use Hive class B1, right? So this is the database we had. And now if we do this select star from department data, right? And if you run this query, then you can see the data, but you won't be able to see the column names, right? So for that, what you can do a simple setting, right? You can simply set one configuration, right, in this Hive shell itself, and after that you will be able to see the column names as well. So those are configurable properties. Let's say always are true, false, or the binary values for those kind of properties. So if you turn it on, then you will be able to access and you will be able to see things related to that in the terminal. If those are turned off, then you won't be able to see it, right? So the property and how to set these kind of configurable properties in the Hive terminal. So for that, the syntax is the set and simple the property name, which is hive.cli dot print dot header, right? So we need to turn it on, like that means true. So set is a keyword, and this is the property name, and this is the value for the property. So set hive.cli.print.header equals to true, and hit enter, right? So now this property has been activated. So now if I do this select star from department name, okay, so here you can see the column names like department ID, department name, manager ID, and the salary. Right, let me paste this property in the chat box, sorry, in the git. All right. So now this is done, and I will quickly go back to the, so local path related things are done. And now quickly what I will show you that how we will be doing it, how we can do it in the HDFS path, right? So first, what, so similarly in the what we used the /temp folder of our local file systems, or the things which can be accessed from the root, and we stored it, or we created a folder there, and then we copied our file there and we executed it. So same thing, what we are trying to do, we will be using a temp space of the HDFS folder. First, we will create one directory into it, and the file which is present in our local system, we will copy it into the HDFS location, and then we will create another table, and in that table we will load the data from the HDFS path. Okay, so first let's access the Hadoop fs hyphen ls, and if I do this, right, you will see lots of files which are already created. So /temp I am accessing, right? So this is the temp of the HDFS file system, right? Lots of things because we have been practicing on it. And what we are going to do now, first we will create one folder in it, right? So Hadoop fs hyphen mkdir to create the directory, and Hadoop fs is the keyword which we keep on using in order to execute the HDFS related command. So /temp, within that we are going to create the folder or the directory name. So that will be Hive data class 2, right? So this is the directory, and I am telling, and this is for everyone. You need to practice this one, right? So just run this command again in your system, right? So that you can create one directory within this /temp folder. And now I had already copied that file from FileZilla to my local machine. Okay, so now I need to copy that file, right, from my local to this HDFS location. So for that one, what I can do, Hadoop fs hyphen put, right, and hyphen put, I need to pick the data from local directory or not from this one. Let's say simply I can pick the data which I have copied into the temp location, and the temp location, it was like Hive class and the depart data, and I am copying this local data, local host or local system data to the HDFS location, and that HDFS location is this one. So this is the source location, and source location points to our local file system, and this one will point to our HDFS file system on the right hand side, right? So now let me run this HDFS ls command on this directory, right? /temp Hive data class 2. And if we do the ls, we can see the department underscore data.csv has been copied into this directory of HDFS location. Is it clear? Is it clear? Are you guys able to do that? Cool. So this is this is our HDFS location. Cool. Now I will start my Hive engine again. Okay, and I will use that database Hive class B1 and show tables. This was already created. So I will create another table, right, with the same schema and all. So create table, right, and this is the create table department data. Let's name it from HDFS, right? And its first column department ID, which will be int, and its second column department name, right, which will be string, and third column manager ID, it will be int, and fourth column salary, it is again int, and after that what we need to use, we need to use the row format delimited, right, and fields delimited by this thing. Okay, let me just cross check. I'm not missing anything. Files, yeah, row format terminated by a terminated by, so row format delimited, right? And after that, what we will be having, we'll be having fields terminated by the comma, right? So we have simply created this table. So this will be a new table, and it will be an empty table again, because we haven't uploaded anything into it. And after uploading, right, what we will be doing, we will try to load the data from our HDFS path, right? So let's create it. So this table has also been created. Now if I run the show tables, right, yes, at this moment, right, we don't need to provide the HDFS location. So that's why don't get confused. So this new table which I have created, it is again the internal table. It is not the external table. That is why I am not providing any, and that is why even I haven't mentioned any external keyword name here, right? If I would have mentioned it, that means this is the external table, correct? So something, this is right, we haven't done. So this is again the internal table, and what we are trying to do here, we are trying to load the data from HDFS to this Hive location. Okay. So, and you can check this one again, run again this part, describe for method, right? You can see this detail again. It is a managed table. Managed table means the internal table, and this is the location in the HDFS warehouse has been created, user and its schema, right? So I think I don't need to copy paste the same thing again into the Git repo, because you have already this definition. Just change the table name and recreate it. And in this table, what we are going to do now, we are going to use the load command to load data from the HDFS location to this Hive table. And how we will be doing it? We will be using this command, right? Load data. So if you remember, and this command, right? So here what we mentioned, load data, we use the local keyword, right? So whenever we are loading data from the HDFS location, we don't mention that local keyword. So in the Hive, if the command load command is written without local keyword, that means whatever path we will be mentioning, that will be a HDFS path, right? So load data, right? And after that, we need to provide this in path, and here what we will do, we will mention this HDFS location, right? And what was our HDFS location where data is there? So remember one thing, right? In this HDFS location, we have copied the files. So don't provide this complete path, right? Including the file name, simply the directory name of HDFS where your file is located, because Hive will not pinpoint, or Hive will not point itself to any specific file or file part, right? Because again, I have mentioned this thing in previous class, that whenever we work with the distributed data, distributed environments, files will be in multi parts as well. So we cannot point ourselves to one specific part or one specific file segment, right? Always just point the Hive, or in the load command, make sure you are providing the exact directory name where your actual file is stored. So only this part I need to pick. Right? So this will be my path. Then just add / here, and I need to add this into table. And what is my table name? This one. Right? So load data has been completed. Now I need to set that property again, because I have restarted my Hive session. So whenever you will restart your Hive session, what will happen? That property, right, which we were setting in order to display the column name, that will be removed. So I need to set that property again. So set Hive dot CLI dot print dot header equals to true, right? And after that, if I run select star from this table, right, we can see the output. This is also clear. Now let me paste this command into the Git repo. So I will just with the hashtag, I am adding a comment here. It like hash, any line starts with hash, you just treat it as a comment for data load from local, and after that here display column name, and here load data from HDFS location. All right, so understood this part? Clear and executed. Awesome. How about other? So see that will be there, right? If we will try to match the speed, right, somehow. So again, I'll be right in behind, and we will not be able to complete the things by time, right? Even something which let's say we're supposed to complete by 6 months or 8 months, okay, we will not be able to do it, because that is why, right, I'm providing all these things in Git repo, and we have this thing, right, recording is available. So let's say something which you are not able to execute at this moment and instantly, still I'm taking very much time, right? I'm speaking very slow, I'm executing commands one by one, providing all the right, like lessons, so you can even miss something, right? And then you can just go and watch these recordings again and try to execute it, right, at your own speed. That is the main purpose, to give you the live class feeling, and after that recordings will be available for you forever, right? So that you can watch it and again just practice all these things, right? And that is the thing, right? Cool. Any confusion? All right, so I think we are good on this part, right? So far we have covered this thing. So we are done with the internal table creation. We are done with the load data from local. We are done with the load data from the HDFS, right? Now, what we will try to do, we will try to create the external tables, right? And after that, I will show you that like what are the typical differences between them, right? So let's move on to that. Cool. So this is done, and now we will work on the external tables. All right, so for the external table part, right, I will again create a new table, and the data which we have stored, right? So again, in the beginning, when I was explaining this part, how this external tables will work, when we created the internal table, we had to load the data either from, you can say, local systems, or even either from the HDFS file systems. But the way external tables actually work, we need to create the table schema, and while creating the table, right, we provide the path of the HDFS location, or you can say the file path, which will be eventually used, or you can say where our raw data is stored. So we don't need to load the data in the external tables, because the external table definition will already be pointing to some HDFS location data, and we don't need to run the load command, and we can simply fire the queries, right? So I will show you that part, how it will be done. So the syntax is simple: create external. So when we were talking about the internal tables, so there we didn't use any external kind of like keywords. So if we are creating normal tables without any external keyword, those will be the managed one. So create external table name, and that will be department data external, right? And we will create the same schema. So department ID equals to int, right? And after that, what we are trying to do, department name, it will be string. And after that, we will department ID, department name, and then manager ID, right? That will be int, and then the salary part, which will be int again, and the other definition, row format delimited, right? And the fields terminated by comma. And now, since it is an external table, we need to point our table to that HDFS location where our source or the raw data is stored. So for that one, how it will be, location in the single quotes, since we are going to use this same HDFS data which we used for this load from HDFS. So we will point our Hive table to that directory. So location / temp, and then executed, right? So we have got the response okay. So now if we run this query, so select star from this thing, right? Okay. What is the reason we are not getting the data? Select star. Why the table is empty? Just a second. Hive data class 2. I have provided the right location. No? So details, Hive location is there. This is completely fine. Why we are getting the empty data? This is strange. Location / temp Hive HDFS. Create external. Syntax is correct. Location is correct. So let's start from department data external. The column names. Why it is not reading the data? Department ID external dot salary. It should have simply worked. So that is the reason, right? In the external files, we don't need to simply we don't need to load the data, because during the time of the creation we pointed our table to that location where simply our data is there, right? So the schema has been just created on top of it, and it should definitely read the data. Let me quickly check, right? Just a second. I was running this one. So yesterday, just a second. So the external table, the 123 dot forward slash data already. This should have created local external path. I ran this command yesterday, was checking. It should go fine, but what I'm missing, I'm just cross checking. Lines terminated by the external table fields terminated by lines. Is the location part? Something is missing. Just let me debug onto that part. This one I already created. This is was working fine. Same. Let me create a table. KLM. This is my location for this one. And let me run it. Table will get created. And I will see the output. Why it is not working there? What is the reason? Ooh, you can see right here, it is simply working fine. So slash tmp Hive class 1, that was there. What is the reason it is not working here? Did I miss something? This is pretty much weird, right? Same thing is executing from Hue, and this is not getting executed from this location. Why? Too much weird. I have placed the data in the file as well. The data is already there. I don't need to provide the HDFS location. I don't need to provide it. Yes, this is pretty much weird issue because yesterday I already tried all these things one time that all commands should run fine, but this is very strange, pretty new, that why it is even getting failed when all the syntax wise and all the location wise data and everything is completely correct. Should be there. We have the file path. Destination path is there, right? Not the internal table. We have created a different table for it, right? Location temp. Weird. So Hive class 1. Let me simply copy this command which I executed yesterday because I have the data in the HDFS location, right? So let's test table KLM department ID, string manager ID, location ID, row format delimited slash tmp Hive class 1. This is the location. Hive class 2 data was there, right? This is also a good idea. Like, let me check. Once data was copied in the HDFS location, let me quickly. So Hadoop fs -ls, Hadoop fs -ls, and this is the path, right? Just a second. Oh God. What? So where I copied that time data was load data department dot csv temp hive class 2. Oh, what I forgot to mention, I guess, the thing is when we did this part, right, when we were creating that external, sorry, when we were moving data or loading data from the HDFS to that part, right, we were using this command, the load data from the HDFS, right? So in that case, what will happen? I literally forgot to mention this part. The data which was at the source location will be moved, right, from the source location in the structured form to the data warehouse or the Hive warehouse, right? So since this has been moved, so that is why we can see this one as a empty file, right? This is the empty directory. Here you can simply see this part, right, where I copied this data, right? Here a Hadoop FS, I copied this path, right? And then this data file was copied to this location. And after that, I ran this Hadoop FS -ls on this folder, and we got this one, right? Let me check one more time. Yeah. So what will happen in case of that one, right? When we were loading the data. So obviously loading the data, something we had on the source HDFS. So when we moved or loaded the data from HDFS to this part, right? So that data was actually being moved from the source HDFS location to the Hive table completely. That means it was erased from the source location. So since here we are going to create the external table, so in that case, what will happen? We need to create this or we need to dump the data again. Let me dump the data into this folder again and then the external table which we created. Ideally, since that table was created, now data have been copied to it. We will directly able to see the result, right? We don't need to create the table again. But yeah, that was weird. I literally forgot about it. Yeah, so let me first set that command, set hive.cli.print dot header, right, equals to true. And now if I use hive class b1 and okay, select start from HDFS. Yep, you can see, right, the data we can see now, right? So first thing, like two three things here to clarify. First thing, when we actually run that part, right, what you say, the load from HDFS to the managed table, right? In that case, data from the source table will be removed. Okay. And uh, in this external table, right, you saw this part, right? Here what we did, we created the external table, we pointed our table to some HDFS location, although file was not created. That's why we were getting empty data set, but column names are there, correct? Now as soon as we moved or we just stopped executing our Hive engine and we came back and we copied our data from the source location again to the HDFS location. So now you can see when we fire the query again, we don't need to create the table because our create table was already pointing to the source directory. We just needed to copy the data. So data, when it is there, our select command will work seamlessly, right? That is why we are able to see the data here. And that is why I am saying in the external table, right, whenever we create the external tables, we don't need to load any data into it, because what will happen in the external tables, right? So let's say we have this path, this is the data, right? Let's say this is the row columnar data simply, right? And this is the Hive engine, and here we have created our external table, right? So this table TB1, it will directly, so definition like schema will be created here, schema here, data here, right? So in this case, in terms of the external tables, this schema is simply pointing to this external data set. So whenever you are firing the SQL into it, right, any Hive query, any select statement, or any information you are using this table, since this table knows where this data is stored, so it is reading it from there, right, and mapping it according to the schema whatever we have created and displaying the output here, right? So that's how things will work in case of the external tables. No need to load any data manually, let's say using the load command, because you are during the like while creating the file itself, we provided this definition and all those necessary paths, right? So that's how it is being done. So when we saw that part, right, the location thing, so there what actually happened, let me now do a quick exit, okay, and let me run this Hadoop fs command again, right? So here you can see now this time data is already in the HDFS location, but when we ran that load from you can say HDFS path, then data was vanished from the source location. But in terms of the you can say external tables, so your source data will be residing on the source location itself. Only metadata will be created in the Hive engine, okay, and everything will be pretty much sorted for you. Cool. So that's how it will be working. Any confusion in terms of this part, I can quickly paste this create table definition for the external one in this Git repo, and meanwhile you can let me know in the chat box if any confusion. Create external table. Yes, so if you have any confusion, tell me. After that, I will show you one more important thing. From there, you will understand what is the exact difference between internal and external table. Okay. From HDFS, okay, please repeat external table creation. So let me reiterate on this, the syntax part, right? So create external table. This is the keyword, right? And this is the table name we have given, and the schema and all these things. After that, row delimited, sorry, row format, then the fields terminated. And this location word, this was not present in the internal or managed table definition part. So when we are working with the external tables, right? So what will happen in this case? We are simply pointing our table schema to the data which is already stored somewhere on the remote location, right? So that's how it is being done here. Cool. So now so far we have seen few things, right? Let me start my Hive engine again, and I will do one thing to make you understand this part, that how it is done. Right now, use Hive class B1, right? So show tables. So both of them, right? This one was also this one was also our managed table and internal table, and this is also our managed table and internal table, right? So if you remember, right, again I will do a quit, that I will show you that when we were creating the internal table, so whatever data we picked from the source, right? So while picking it up, what happened? it moved data from what do you say? It moved data from the source location to the Hive warehouse, right? And HDFS we are using as a warehouse itself. So that time, what did you? What I actually showed you? Let me first Hive class. Just a second. Not this one, right? Hive. What is that? Yeah, not this one. Okay. So that time, what I did show you Hadoop fs -ls. I will show you that since we have created the internal and external tables both, I will show you what you will see in the warehouse, right? So Hadoop fs -ls /user /hive class b1.db. First that I need to type this path warehouse, right? So here we can see department data and department data from HDFS directory. Now, can you guys tell me what is the reason why we are not seeing the third directory in this warehouse HDFS location, which we created for the external table? What is the reason? It's because yes, so that is the main reason to make you clarify, right? When here we created the internal tables, or these two, right? This one and this one was the internal table. So for the internal tables, metadata will be created in the Hive, and the data which we are loading from the source locations, that will also get copied to the HDFS warehouse location. That is why only two directories we can see in the HDFS warehouse location: department data from HDFS. We are not seeing any directory for this external table, because our external table, this is the table which is just pointing its schema to the external location, and we can query data from there itself, right? We don't need to load the data from any source to the external table. Get it now? Like after watching this path, at least I am pretty much confident that you guys able to understand what is the prime difference between the external and internal tables, where data, in which case data will get copied, in which in case data will not get copied. Is it clear after this part? At least then there will be one more part, right? After doing that one, everything will be cleared in terms of the internal and external table. Okay, so now okay, so for the internal and external table, again, right, quickly I will write it down here. So internal table, what happened with internal tables here? Two things will be created. Internal tables, metadata in Hive, also original data, original slash raw data in Hive. In terms of the external tables, only metadata in Hive. All right. So this will be the simple difference between these two. That is the reason, right? So when the Hive engine right, will try to load the data in the internal tables. That is the reason we are able to see the data in the HDFS warehouse location, right, for these two tables, because these two are the managed tables, internal tables, right? That is why the data is in the warehouse. Okay, right? So now let me do this part. And I'm pretty sure this practical example which I will show, after that everything will be clear for you, right? Not to worry about anything. Cool. So use Hive class B1 show tables. Now let's try to drop the tables. Drop command, everybody knows about it. Drop means when we want to uh, delete the tables and data from our databases. So there is one quick question for anybody who knows, right? So even in the SQL, and this is also one important interview question, there is one more command named as the truncate, and there is one command named as the drop. So what is the typical difference between the truncate and the drop command? Yes, correct. So the drop command, so here we talked about two things, right? So every table will have two things. It will have schema and it will have the data. Okay. So when we run the truncate command, so truncate command will erase the data for that particular table, right? But it will keep the table structure. It will not delete its schema. It will not delete its metadata part. But when we talk about the drop command, so drop command will delete the data as well, wherever it is stored physically, and it will delete its structure, or you can say its complete metadata or the schema. Everything will be deleted. So that is what we are going to try with the internal table and with the external table. Let's say if we run a drop command with internal table, what will happen? And when we run a drop command with external table, what will happen, right? So drop table, first I will try to run a drop command on this internal table, right? So I have ran it. Now drop another internal table. Both internal tables have been deleted, right? Now drop this table, external table as well. Cool. So we have dropped all three tables, right? Now let's do a exit. First, let's say since the everything has been deleted, if I run a select star from, right, let's say this internal table, obviously we will not get anything because this table is not there. So when we are getting table not found, that means metadata has been deleted for sure, right? And same command, let's say we are running for other two tables, right? From HDFS, we are getting the same error. That means metadata has been deleted for internal table as well. Now data external, right? Table not found. That means the metadata for all three tables has at least deleted from the Hive. We are clear on this part. Now moving on to this part, let's jump into checking the data, right? So let's reiterate our location. Hadoop fs-ls. This was the warehouse, right? Which was for our database was being created in the HDFS. Now, if I run this part, right? Hadoop HDFS ls on this part, what we see are we are not getting this one, right? Earlier when we ran this command, so what happened? We could see this one, right? The table and data was created in it. But now after doing the drop command, what happened? We are not able to see anything here. It is completely empty. So this is the most important part to understand here. Now let's check that HDFS location which we were using for our external table, right? So this was the location where we have pointed our external table, right? You can see the data file here. So now just let me know in the chat box quickly, did you get the exact difference after running these commands practically? What is the difference between internal and external table and why these scenarios are happening? Right? I hope, like, based on this practical part, all looking at all those HDFS locations, warehouse locations, you would have understood it clearly. When we create the internal tables and we run the drop command, the metadata will be removed and its main data, which is stored in the warehouse, it will also remove. But when we create the external tables, only metadata will be removed. But since it was just a pointer, right? It was just a pointer. We have just cut that thread which was pointing to that particular source location, right? But my data is still safe there. So now you can understand the value of having the external tables. So wherever you see that your data is very much critical to you and you cannot actually lose it, you always want it to be present at the source location. So you will always try to create the external tables from the safety perspective, right? But creating the external tables sometimes would be it can add some you need to compromise on the performance side little bit, because external table sometimes the data might be present on the remote HDFS location. So whenever you will be firing the query, data needs to be moved right over the network. So it will take some time. But when we talked about the internals, right, Hive internal, so let's say even the data was stored on the remote HDFS, first it is being pulled and getting stored in the warehouse of the Hive. So data locality somehow is there. Hive will be easily able to get that data which is eventually stored in its warehouse. So we will get some performance advantage on the internal table side, right? So that is the difference. But data is something which is very much crucial. We can compromise on the runtime sometimes, but we cannot afford the data loss. Understood, guys? I hope from now onwards I don't need to repeat this thing, what is the main difference and how to operate with the internal tables and external tables, why and this and that. I hope everything I have made it clear to you. Yes sir, cleared. Awesome. And still there will be any doubt, we will be covering it in the doubt session part, right? So not to worry about. All right, so this is the part for this one. Now let's move on to the next part. What I have covered so far, I have covered the create databases part, tables, internal, load from local, load from HDFS, and create tables, right? Create the external tables. Okay. Now what I'm gonna talk about, so far, right, we have saw like simple kind of data types, right? Let's say we were operating with the integer, we were operating with the string sort of you can say string sort of data types, right? So the advantage with the Hive sort of engines that they have also the feasibility, or you can say they have this kind of you can say advantage, or they have the capabilities where they can operate on the advanced type of data structures as well. Let's say in your input file there is a column which is somehow acting like a array, or you can say acting like a map, right? So these are also a data structures. Arrays are data structures where homogeneous kind of data will be there, right? So it has its own iteration process with the help of the indices. And when we talk about the map or the dictionary kind of data structures, so it will have the like it will have the keys and it will have the values. So the implementation on the map type of data structures is also a little bit different. So now we will be looking at that part, that how it is being done with the sample data set, and how to work on it, and how to declare those kind of data structures, right, in the create table command, and how to work on it, right? So let me talk about it. Okay, so internal table. So I can see you guys are saying this will be enough and this will be overwhelming for today, but I wanted to cover two more topics, serialization, deserialization, and this part as well. What do you say? The arrays and maps. So let me know. I mean, I'm pretty much fine. I can take up the doubts part. Okay, yeah, if you guys want to have a break, then yes, let's take a break for 5 minutes. Okay, and it is 38 5. Let's meet at 12:45, and then we will continue on the this part, data structures part, right? So today I'll not cover the survey part. I will let's only give you the examples of working with the arrays and maps. Then the most important topics, those two important topics, right, which are the partitioning, bucketing, and the UDFs and the survey, we will be covering in the next week, right? So let's meet at after 5 minutes and we will cover the remaining part. All right, so are you guys back? Okay, so let's quickly see some examples of working with like array and map type of data structures, and then after that we will be having our doubt sessions, right? So let's work on it. Awesome. So let me start this part. Hive. But before that, let me prepare a data set for you, right? So that you can see how this this type of arrays or these things will be looking, right? So for that one, what I'm going to do, I'm in the pwd vim. I'm going to open a vim editor. So if you are in a Linux box, you like, let's say you are working on the VM and all, so you can use it like vim command and open a file there. If not, then what you can do, you can simply do it in your local notepad as well. Whatever I'm typing here, the data set, it will be a 3-4 line data set, a small data set, right? Then you can do it in your end as well in the local notepad, and then copy to the virtual machine, right? So here, just a second, I have vim, and after the vim part, it's a array data, right? So this is empty file I have created, and what I want to do, I want to add a couple of records here, right? I want to add a couple of records. So records will be, first is 101 and a myth, then Hadoop, then Hive, then Spark. I will upload this data set as well, don't worry. Big data, right? This is the first record, 102, and so myth, then Hive, Uzi, and Hadoop, and Spark, and we have Storm. Third record, Rohit Sharma, not Rohit Sharma, Kafka, Cassandra, right, and HBase. Right, so these are the simple 3 records. So the data set is something like very simple to understand. We will be having IDs and names, and this third part, right, which is sort of the skill sets in the descending order, like the Hadoop. Amit knows Hadoop well, then after that Hive, then Hive, Spark, then big data, right, on all these things. Similarly for these candidates, right? So here now what we are going to do, that we will be saving this data set, and let me make this data set available for the audience as well. So now you might be thinking that the thing you should notice here, so eventually these are the 3 fields like comma separated, and this field is something which will act like as which will act like a array for us, because here we can see multiple elements and these are separated by colon, and this separator can be anything. Even this data set or field we have written here can be pipe as well, and here can be, let's say, hyphen as well. Here it can be any other uh, any other sort of delimiter we can use, but usually this colon, hyphen, pipe are used. So this is something which will act like an array. So we need to create our Hive table in such a way so that we can deal with these kind of data values, and how to operate on it. We will be looking at all those kind of examples, right? Now let me copy paste this data set for you guys. Just a second. Let me create a new file. Create a new file. Oh, sorry. Array data.csv, right? This has been done. New file, and now this file should be available for you all. Again, folks who don't have this GitHub repo link, I am pasting it in the chat box. Right? So this one we created. Now we will just store, right? We have saved this file, and okay, I forgot to name it like array data, right? So array data.csv, right? So ls. Now this what I will do, I will move this file array data.csv to data folder, right? Now cd data, this is done. So this time mostly how I will be loading it using the local input path. So this data file, right, it is present in my local machine. Now first I will copy it into the local of temp so that I don't get any access related issues and all. So same thing, right? We have /tmp and Hive class, right? This is the folder we already have. So what we are going to do, cp data array data, and I will paste it in the temp and then Hive class, right? So now this data is available in the /temp/Hive class. This is not the HDFS temp. Again, this is the local system temp, which we are going to use for the load local data, right? So now it is here. Now let me start my Hive engine. Okay. So here we will try to create a table which will deal with our data set. So here again, if I open our data set, right, which is like this array data, right? So you can see this is a third field, right? And how we want to work on it, right? We somehow want to deal with this one so that the fields or the values which are separated by colon should be treated as a array, and we can do multiple operations on it, right, in order to get the size of it, in order to get the individual element values, accessing anything specific part or sorting, and all these things we can do on top of it, right? So this is the typical way to deal with the you can say advanced data structures in the Hive, and mostly we call it as a collection, right? So map data structures is also sort of collection, array is also collection of data elements, right? So in Hive, that is something which will be called as the collection. So let me create a table for it. Use Hive class b1, right, and create table employee, and within that we will have a column id which is int, and after that we will be having a name column which will be sort of string, and after that we will create another thing which is skills, and it will be named as this one, array of string types, right? The third value is, right, in the raw data it is yet not a array, right? It is just a simple, you would treat it like a string has been written, but we are creating our schema. We have not defined other properties as of now. So defining our schema, what we are saying, the third field which I will read from the input raw data, it will be of array type, and array of strings means the values which will be in that array will be the string values, right? So that is how three fields we have defined. After that, row format delimited, fields terminated by comma, and after that third property which we need to define in order to deal with these data structures and operators, collections, right? Our collection is something, collection items terminated by colon, right? So this is the table structure we have defined now, and hit the enter. So for us, table has been created. Now we just want to load the data, right? So for that one, I will quickly refer this load from local command, right? And I will come back here, and here temp hive, and what is the data we have? Array data.csv, right? And table is employee table. Employee table. Right? So data has been loaded. Let me paste these commands for you all in the Git repo. Okay, just a second now. Comment is work with array data types. So I have pasted for you all. And now after that, let me set that header property hive.cli.print header equals to true. And if I run this command now, select star from employee table, right? We can see that earlier how it was looking like in the raw data, right? If I tell you this, if I show you how this was looking like array data, it was looking like this, simple like a string separated by comma. Now, once we have applied and we have defined our array data field, and we have defined these properties, and when we are running our commands, so here you can see this skills field is typically acting like a array. So in array, if you have seen it in different languages like the Java or the Python or something, it will be in like a square bracket and elements will be there, right? So this is how it will look like. Now you might be thinking that if I want to operate on it, then how we can simply work on it, right? So let me first show you that what kind of operations, right, what all things we can actually get from. Now this is the array. So array is a data structure, so it contains some number of elements. So we want to write functions, right? And the functions which I'm going to write next, these are the functions which will always be applicable on different kind of collections like the arrays and the maps as well, right? So it will be applicable for both. So we are going to apply those functions now. First, we will try to print the size of it, and let's say not size, let's say what we are trying to do, we try to pick the first skill, right? The first element from this array, like what is the most prime skill these employees actually know, right? So whatever is at the first place is, let's say, their prime skill. So select first, let's try this out, how these things will be working. Normally, I'm just printing ID and name, that how it will look like, so that I can write other steps for making it more readable. Okay, ID and name. So both have been selected. So select now, right? ID, comma name, and we had this skills field. It acts like a array. So values can be accessed from the indexes, and we will name it as a prime skill. Okay, from employee. Let it get completed, because somehow it will be running a map reduced task because it is operating on these kind of it is doing some operations, right? Because in the distributed environment, it will try to pick the uh, element, right? It will iterate over these elements. So I think I have mentioned this thing. It should be not 1, it should be 0, because we are talking about the prime scale. So array, so here in this first array object, right, we can see one in total 4 elements, right? So 1 2 3 4. So if we want to access any element from the array, typically I'm talking about normal array data structures. So what will happen, we will we will use the name of our array in the square bracket. We can give the index, right? And the index will be the exact location for which we want to pull out the value. So here, for in each array object, we have, let's say 1 2 3 4. Here in total we have 5. Here in total we have how many? 3. But here we were concerned, the use case in front of us was to pick the prime skill. So whatever skill which is written at the first location or the 0th location, if we talk in terms of the array indexing, so it will always start from the 0th location. So that's how it will be. I need to change my query. So skills, and in the square bracket I have written 0. That means pick the element or pick the first or the 0th element from each array object for each row, right? And now if I execute it, we will get that one, the answer we wanted to figure out. Let it completed, and then we will see the output. Cool. So here you can see that how easily we could have accessed our prime skills, or how we can simply fetch the uh, elements from the array object. In our case, the table we have created, the skills column, right, is something which is hold, or which is a name given to a array data structures, and that is why we are able to access these values. Yes, whatever you want, right? It's up to you. You can even create external table, internal table, copy it from the HDFS, right? So it is as simple as that, right? You can do it by any way. Now you know multiple ways. It's up to you. Whatever is working for you, just keep on doing that. So if it is giving some error, maybe some mistake, right? Now after, since I have ran this query, I will paste this one as well in the Git, right? So that you can understand that how it is getting used, and how we are trying to access the prime skill, or how we are iterating it using the index, right? So let me copy it and paste it in the simple chat box, or in the Hive table 2.txt part, right? Here, let me name it like this one, right? Hash get element by index in Hive array data type, right? And now I have pasted this query. Let it commit. And now I am going to apply few functions, right, which are collection functions typically designed for these kind of data structures itself, right? So let me apply those kind of functions. So first function is something, right, what all things we can do with array, at least array type of column on an array kind of object. So select, right, the first function is basically calculating the size, right? So each in this, right here, you can see each array object has different number of values into it, and we can even calculate the size of it. So here, let's say ID, first column, then name, right? And after that, size of skills. This will be applied on each row as size of each array, right? So this is the first function we have applied. Now, another function which we want to apply, what we want to check, we want to, let's say, somehow filter out all those kind of employees which knows Hadoop, right? They should have Hadoop as a skill set. So what we will be trying, we are trying to derive a one more column, which will be a kind of true false value. And what it will check for each array object, it will try to find Hadoop exist in this array or not, like it is doing a kind of lookup. So for that one, what kind of collection function we can use? This one, array contains, right? So array contains, and here what is our input array? It is skills, and which value we want to check, whether it is present in the array or not. We want to check Hadoop, right? So this is the another function which we can use, right? I will name it like knows Hadoop. This is the another field we have created. Now, after that, let's say we want to sort this one. So sort array, and we have skills, right? We have applied in it from employee, right? And hit enter. We will see the output. So I hope now running it from the terminal, you will be getting complete feel that how like number of reducers and all these things are getting created. So here number of mappers are 1, number of reducers equals to 0, because there is no aggregation and those kind of things are involved. These things can be calculated individually on their mapper task itself, right? That is why number of reducers were 0. So here for the last column, right, I forgot to give a alias name. That is why by default it has picked underscore C4. But here we will see the output ID and the name, size of each array. So here in this one, size of this array is 4, size of this array is 5, size of this array is 3, right? Let's verify the output. So size of array 4 is 5 and 3. Now another field which we derived, it was knows Hadoop, right? So for that we applied this function, array contains Hadoop. This was the lookup we were trying to apply. So in this array we can see, yes, Hadoop as an element exists. That is why we could see true as a value. In this array we have seen like Hadoop is something which we can see, right, is present, right? So this guy, right, Sumit also knows Hadoop. That is why we have got true is the as a resultant. Now in this array, if we try to do a lookup for Hadoop string or keyword, we won't be getting it because it is not present. That is why we got the false. So now you have seen the how this array underscore contains function work and how this size actually works. After that, what we have applied, we applied one more function, and that is sort array. So whatever array is actually here, for that one, the elements, it will be organized in the ascending order, right, within the array itself. So you can see, right, earlier how it was looking like Hadoop was here, then Hive, Spark, Big Data. But when we sort these elements in the lexicographical order in the array itself, so whatever will be the character which appears first in the alphabet, based on those basis, it will be sorted. So Big Data will come first, then Hadoop, then Hive, then Spark. Same for this one, Hadoop will be here, Hive, Uzi, Spark, Storm, and then C for Cassandra, and H comes after that, and K comes after that. So that is how these things are getting sorted here as well. So any confusion working with the array data structures, how to iterate on it, how to access the values with the help of indexes, and also applying these functions. Clear? Good. So let me also paste this query. So I have pasted this query, name it like as sorted array. Cool. So now we will look at one more data structures for today, and that would be the last one. And then we will move on to the doubt clearing part. And the next one, which we are going to look at, is basically the map, sort of like where the values will be in the, you can say, key value sort of pairs, right? So for that one, how we are going to do it. So just a second, I will prepare a data set for that one as well. Okay, so let me again do a exit. So quickly, let me go into the CD data, and here I have map data.csv. Okay, this is the file I have created, and under that, what I'm going to do, I am basically going to create few data sets. Let's say the ID, languages, and the properties. Okay, just a random data set, or how it can be done. So let's say it will be a sort of employee data. So again, let me use that Amit. Okay, and here the data which I'm going to create here, let's say age 21, and then pipe separated something. It will look like gender equals to male, right? Now 102, and Sumit, let's say age 24, and gender equals to this one. Now 103, Mansi, age 23, and gender female, right? Now let me also copy this data set for you, and we'll share it in the box. To just a second. Ta-da-da. 101, and let me create a new file. Add file map data.csv, and it is here now, committed. And here, let me simply save this file, right? And from here, I will copy this map data to our /tmp Hive class, right? So this data has been copied there. And now I will go to my Hive engine. So folks who, let's say, don't know about the map data, let me explain it quickly. Map, or any time, let's say you got to know about the JSON data set, right? So that is something which will be covered in the serialization and deserialization. You will get more information about it. But map is a sort of data structure, right, which is very, very easy to understand, not very difficult something. So arrays we talked about. So how arrays will be actually looking like. So array will look like something this. In this square bracket, we will be having, let's say, one element, and the another element is 10, 20, and 40. So it will always store, array will always store the homogeneous kind of data. Means if one element is int, all other elements will be also integer. Same, if it is one is a string, other will be string as well. It cannot hold the heterogeneous kind of data. Now talking about the map data structure. So map data structures or data type, what you can say, like custom or advanced data type. So map, its definition is it will always have a key, right, and one value, right? So folks who have not seen the JSON file as of now, and let's say you have seen the JSON, So how this JSON file look like? It will have the starting and ending curly braces, and then there will be few keys will be written. Let's say age will be written like this, and after this colon, one value will be written. And then let's say age is here. Sorry, after the age, let's say gender is written, right? And then let's say it will be male, something like that, right? So that is how this map data structures it will be look like. Let's say I have assigned this map data structures to variable m1. So when in array, right, let's say our array name is arr. So this is the value, right? This is the full value which we have assigned in this variable, and this is the full value which we have assigned this variable m1. So when we wanted to access any element from the array, so how it was being done, we were providing the index, right? So let's say I have or let's say we have 10 elements in array, right? So I can I can definitely get the different values. So if I sometimes type arr 0, so I will get the first element, because array indexing start from the zeroth, but it will zeroth index will point to the first element. And if I type the arr 8, so that means it will point to the ninth element of the array. And that's how we will be able to iterate over array type of data types. Now talking about the map type of data types, it is simply key value based. So let's say m1 was my variable where map type of data was stored. So in the square bracket, I can simply type the key name. So let's say I want to get the I want to get the data for the age key, right? So I can simply type my variable name in the square bracket. I can type age. Let's say this iteration we were doing for the first row. So in the first row, the value of age was 21. So this will be our output. So this part is clear, like how array and map data structures or data types actually work on nutshell and on a higher level view. Yes, like dict in Python, exactly. So map is definitely, this is a common terminology, right? Will be used across the data structures algorithm and the programming languages, but sometimes they will be also having a different convention, like dictionary where key value mapping, where some you have some keys and values, and exactly like a JSON data type, right? So now we will be looking at the working part. So we have prepared our data set. Now we will be creating the actual table for it, right? The table definition for it. So similarly, last time we use again this array map. This will work like a collection for us. So same type of table definition we need here, right? So how it will be here? Uh, create table. What was the employee map data? And first is ID is int, name as a string. Okay. And after that, we will have the third column, which will point to this map part in our data set, right? And our data set, which actually looks like this one, right? So it will look like the details. Let's say details will be sort of map type, and map will have two things, right? One will be key and one will be value. So we need to define what is the data type of our key and what is the data type of our value, because it's not necessary that here, right? As I have written this thing, you can see, right? This one age, which is kind of a string, right? And it is having integer kind of value. So it is not necessary that the keys will only this type, right? The string, they can be integer as well, right? So that is how we need to define the data type for our string. Sorry, we need to define data type for our key as well. We need to define data type for our value as well. So here in our case, how we are going to do it, it will be the string type, right? And after that it will be the another string type. Okay, now we have simply stored it. Now let me row format delimited, right? And fields terminated by and after that collection items, right? Terminated by pipe. So here, if I go back to our data, so this is the whole collection. So this is the first item, which is a key value pair, and this is the another item, which is a key value pair, and these two items are separated by the pipe. So I need to help my Hive engine to understand this part. That's which separator is being used in order to separate these two items, right? So for that one, we have defined this thing: collection items terminated by pipe, right? Now third, since array, it was pretty much simple because it didn't had complexities of map, dictionaries and keys and values. But since this one is pretty much specific to the mapping, we need to configure few like keywords and configurations for the map as well. So map keys terminated by this colon, right? What does it mean? So here each item, let's say gender colon F, age colon 21, right? These are the multiple key value pairs. So I need to help my Hive need to understand this part. Let's say we have multiple items in the collections. So how these collections are even separated with each other. So Hive will by default understand whatever is written on the left side, that will be the key, and whatever is written on the right side, that will be the value. But it needs to know that which separator is getting used in order to separate the key and value. And here it is this colon part, right? So that is what we have mentioned here. And now if I simply run this part, right, so our table will get created here. Now we can see table is being created. Now first let me paste this query for you in the chat and the Hive class 2. Just a second. So this is the table for map data. Right now we will try to load it as well, right? So whatever data, let's say I had, I use previous command to load the data in array. I will quickly use it. Just do a copy paste, and the name was employee map data, right? And after that, the name of the input file was the map data, right? So data has been loaded. Now if I simply run this part, right, select star from this table, right? So you can see how easily it has been created as a kind of dictionary. Earlier it was how your data was looking like. Your data was simply, let me first paste this load query. Your data was simply looking like this, right? This way. Let me put it and commit merge. So if I go back here and I open it, map data CSV, so it was like this. Now it has exactly been converted into this dictionary kind of data type, right? What we were talking about, right? Which I showed here, right? Simply it has been converted into that one, right? So now let's apply few functions on it as well, like the way we did for the array, right? And we will try to apply like the size. So here if you see each element, or here if you see, right, each dictionary object will be having two elements. Elements means we are not counting this one and this one as a separate element. So one key value pair is a one element, right? So that is how we can calculate the size. And if we want to know that in each dictionary object what is the number of keys and how the number of values, right? So these kind of operations we can also fire. But first, the way we iterated over the array, I will show you that how we can do it on the how we can do it for the, you can say, the map data structure. So select what we want to do. We want to print the let's say gender of each folk here, right? So ID. First let me set that property, right? I forgot to the header part. Hive dot cli dot print dot header equals to true. Okay, and now if I write this part, so select ID comma name comma this one. So we had details column, which will is our map kind of data type. So details, and within that, as I said, we can pass the key name, right? And for each row, it will pick the corresponding key value and will keep on printing in front of each row, which we will be getting in the output. So employee gender, right? From which table? Employee map data. Right, so let it get computed and we will see the output that only ID and the name and the gender value will be printed in the output. Let it get computed. Cool. So we can see this output, only the ID, name, and employee. And how I just specifically selected that particular value from this type of data type. Just it is a simple key value pair, right? So I use this part, the details, like the variable name, and within that I pass the key for which I want to select something, right? So that's how I have done it. And let me paste this query as well. Sorry, just a second. It will be array Hive class 2. Yeah. So that is how we can iterate on it. And after that, let me apply those. Let me print few more things, right, for you to get more clarity of it, that how you will get it. So ID I will select, name I will select. After that, details column I will be selecting, and I will use this size function. Within that, I will pass this details, right? I want to calculate the size of each map object which has been created in our data set as size of each map. After that, what I want to check, map keys. Let's say each whatever number of maps have been created in the data set. So what are the distinct keys in each object? Because that is something which can be different, right, for each row. Okay, so map keys as distinct map keys. And similarly, we will also try to get the values as well, right? How to get the values, the way we have checked the map, you can say the map keys. Similarly, we can check the map values as well, right? So comma map values details as distinct map values, right? Then from employee map data. Cool. So here we can see ID, name, the details column, and size of map, which, so this is like based on the terminal, right? We cannot see proper alignment of the columns names, right, with their values. So size of map 222, right? In each map, only 2 key value pairs are present. Distinct map keys in each map object. So the first part is the key, right? So age is one distinct key and gender is another key. So we have got the list of keys which are present in this each map. Similarly, for each row in each map, what are the distinct values, right, which we have seen in the map object, right? So here 21 and male, this is why it is in the first row, then 24 and male, then 23 and female. So that is how we can use different collection functions over the map data structures, right? So let me paste it in the this one, right? So map function, map functions. All right. So any doubt on this part? Because that was the last thing I wanted to discuss today. And yep, that will be done. So I hope these data types are also clear to you, correct? Awesome, cool. So now, as yes, you guys said, because today I was also thinking to complete the survey part, serialization, deserialization, but I think the starting part took time. Okay. Starting part, because you guys were little bit confused on the internal, external, and I had to explain everything from the that perspective, right? Like where you can see the output and all those things. So those two more data types, right, you can first try to explore it by your own. And why I'm not discussing it in the class, because those are not getting used at all, right? Not getting used at all in terms of like very limited and rare use cases you will see where struct and union are getting used. But map and array is something which is very frequently you will be getting in your raw data, and you need to manipulate data on it. So whatever is getting frequently used, my focus is to first get your feel of that one, and then discussing all those things in terms of the assignment and other things. Cool. So I think now we will be moving on to the doubt clearing part. But guys, for the next week, just come up with the like I will make sure you have revised all those things, whatever we have discussed today, so that we can invest more time to understand those advanced topics, partitioning, bucketing, surveys, join optimizations. Those are the things which needs more effort and more clear understanding. So make sure you don't have any sort of doubt, right, before coming for the next classes. Okay, just revise all those things, and once we will end the Q&A session, I will also give you one theoretical assignment, right? It's nothing much, right? You need to design or develop something. It is just I will give you one, I will provide you or talk about one data set, and whatever operations we have practiced today, I want you guys to repeat everything from the scratch, be it the creating internal tables, copying file to the local file system or to local HDFS, then creating the external tables, dropping the tables, right? running all those commands which we have talked about, and basically like how to operate on this thing, right? The array data structures and the map type of data structures, right? You need to just repeat and revise all those things. And once like our Hive part is completely done, partitioning, bucketing, and other things, then I will give you a decent assignment, right? It will have a good details about the data set and what kind of queries you actually need to write, right? So all those things will be covered once that part is done. But the before coming for the next classes, the assignment for you all is to repeat all those things by yourself from the scratch. Just listen these recordings again and again, understood the part wherever the confusion was, but try to practice these things by your own. Correct? This is the assignment, and I will give you a link for one data set which you need to download in your local system, right? And you need to operate on that data set. Whatever you will be doing moving forward, you need to work on that one, right? Understood? But let's first start with the Q&A part, and meanwhile I will give you that link. So again, same practice, one by one you can raise your hands, right? And I will unmute you all, and then you can ask your questions one by one. But just a second, right? Let me take a deep breath for 1 or 2 minutes. Just a second. All right, so now one by one, I will unmute you all and we'll have, and just a second, folks, let's say who don't have any doubt and probably want to leave the class, that is also fine. But if you want to clarify a few things, you can stay here, not an issue. But let me give you that link, right, for the data set, which you need to download and practice the things. So for that one, we will be now practicing the COVID data set. We will be doing our practice on this COVID data set. So let me paste this link first of all, right? I will edit it. I will add it in the Hive. Sorry, I will add it in the Git repo as well. I will put it in the Zoom chat box as well. So assignment data set, right? So link has been pasted in the Git repo as well, and I'm sharing it in the Zoom as well. Just click on it, and I'm sharing my screen. Then you can see that how you need to. This is basically nothing, simple Kaggle data set, right? So let me share my screen and show you. So once you will open that link right here, right, you will come on this site and you will see this download button, right? And you will be able to download this whole CSV file. So now first give a read to this Kaggle part as well, the data set, what this data set means, what are the columns here, right? And how that is being derived. Then you need to work around this data set and try to create tables in your Hive, try to upload it. And if you are good enough and understanding of the data and want to write some queries on top of it just to play around it, let's say doing a group by filtering or any kind of thing by your own, that would be a good practice. And I would be even really happy if you guys can come up with those kind of queries and put it in your Git repo, that what kind of queries you ran on this COVID data set, what kind of output you generated. That would be very, very amazing, right? So this is the next assignment for your class, and the big project we will be doing once I am done with the partitioning, bucketing, and all those things. Understood? Any confusion? Where and everything will be working, right? So not to worry about that, like why, where, and other things are not working. So everything will be working, right? So that is the part. So the link shared by you will available in the resources section. It will be, yes, I will yeah, I will share the GitHub repo link. So everything you can find in the GitHub repo, and you can also, yeah, I will share this dataset link with the team, right? So that they can put it in the resources part, right? But still make sure whatever we have been doing so far, everything is committed to the Git. So Hive class, right? So Hive class one file is there. Let me delete it because that is of no use. But array data.css is here, department data is here, map is here, hive class.qtxt. You need to follow in order to read all those commands. And even I have pasted this link there as well, right? I'm pasting it here again so that you can copy. Cool. So let's start with the Q&A. All right. Participants. Okay, so first in line, Paresh. Yes, Paresh, go ahead.
Hello. So while executing Hive, we're getting one something called warning as B line. So what exactly is
So
that
that
B?
is an warning. Some, let's say this Hive shell might be getting deprecated after some time, not at this moment, maybe in next releases and all. So that is just a warning. You don't need to worry about it. There will be another way to interact with the Hive engine, probably not the Hive shell. It will be a beeline, right? That will also work exactly like a CLI, but that warning is simple warning, right? That nothing to fix about it.
And one more follow-up question, just regarding the different file format, like
Mhm.
Abro, Parquet, ORC, and also with the compression, different compression tools like Snappy and also. So which one to use in which scenario? For that, if you can give some insight.
Yeah, so basically, so mostly in Hive, the recommended thing is the ORC file format. Either you can work with different file formats, not an issue, right, in Hive, but ORC is something which has been tested with Hive, and the Parquet file format is something which has been tested with the Spark, right? I'm not saying this thing. This is something which is on paper and have been tested over the large number of the data sets and the large number of clusters, that Parquet file performs better with the Spark, right, and the Spark applications. But whenever we are supposed to, let's say, store data in the HDFS and want to query it via Hive, ORC is something which performs better with it.
Anything regarding Avro?
Avro is something, right, which is not very much preferred in terms of the analytical queries. So Avro is something where, right, it is much more preferred in terms of the streaming data sets, right? Because first thing, it doesn't provide that much of a good compression, right? Another thing is that it is like serialized. It can be easily serialized, okay, and basically row type of column. It is not a columnar file format. It is a row based file format, right? So those are the things. So mostly in the real-time data applications or pub/sub models, right, you will see Avro is getting used wherever we are supposed to work on write heavy operations, like frequently writing on something. So Avro will be used there most specifically, but ultimately it will be Parquet, ORC most of the time. And if, let's say, companies are working on JSONs and CSVs.
And also regarding the compression tools like Snappy, Bzip, and all those things.
Mhm.
So where to use that?
So these are things, right? These are the configurable things, right? Snappy is something which will do a block level compression. So whenever, let's say, you are configuring your Hadoop, right, and all these things, so there you can configure these properties. And even in this Hive as well, right, when we operate on the Hive terminal, there are on the Hive official page, right, there are multiple properties listed down. So one property, let's say I was talking about the hive.cli.print.header is true. So similarly, let's say when your Hive is dumping data into the warehouse, which is HDFS, in that case, you can set this property from Hive CLI itself, that this is the property compression, which compression technique you want to use, right? Then equals to value, you can use the snappy, right? So block level compression you can achieve from here and you can configure it.
Okay, thank you.
All right, let's move on to the next question. Just a second. Yogesh, next.
Hello. Just few queries I have. I was noting down. So my first question was like when you were doing the table thing, right? So the external table, the pointing source for it is the Hadoop or or the Cloudera local system or the Hadoop Hive thing. What was the data source for external table?
So for external sources, right, data source will always, so that is why I don't want to confuse you much on that part. So just think HDFS, right, is something which is a distributed and persistent storage system. So it will always, like whenever we talk about the external tables in Hive, it will always point to the tables which are stored in the source HDFS, not any local file system.
Okay. So source SDFS means the normal Hadoop
Yeah,
and not
normal
the
Hadoop, like
Hive
you would
warehouse,
have set up the
not the
Hadoop
Hive
and then
warehouse.
the HDFS component. So
And
wherever
in
you
that,
have stored data in the HDFS, you can point your Hive external table to that one.
do that. And Hive warehouse is different, right? Hive warehouse is
Yeah,
like
Hive
Hive as a
warehouse, right?
service in
That is why
Hadoop.
I'm saying you guys don't need to get confused. Maybe you are just getting confused with the term names. So HDFS is, let's say, a very big pool, or you can say a lake or ocean, right, where your data can be dumped, right? Even on that pool, right, you can create multiple sections where you are putting some sort of data, and other side you are putting some sort of data. So
Okay.
within that large pool, I have allocated one section for my Hive to use it as a warehouse. Means
Okay.
whatever data will be coming from here and there, HDFS sources, and it will be dumped into the internal tables that will be flushed to the Hive warehouse, which is eventually again a HDFS part.
Okay. And related to yesterday's lecture, like when you were talking about the Hive architecture, you mentioned about the planner thing, right? And in that you said like it goes with the best plan, which is like less cost and everything. So you gave an example of like a query, a basic query you said where like if you want
Where
select
and
all
group by.
from employees. Sorry?
Where and group by.
Yeah. So you said like select all from employees where location is India and group by department.
Yeah.
So there were two scenarios. Like first one was go with where clause first and then group by, or the second one was group by first and go with where.
Yeah.
So obviously then cost for was first one was better where we are finding location and group by. But my query is like in this, if I'm writing any code or some source any query, so the output should be based on that query only, right? Because if I'm typing these two separate queries, I get different outputs. So how does it do? Like internally, it plans like because it is something, right? I'm trying to execute something, but then Hive is internally finding a different path, and like I'm little confused there.
So that is why I'm saying, see, so path could be different, right? So you don't think in that way that you have written two different queries, or let's say even a query, and you want some output for it. Okay, so your Hive planner or something will not change the executional sequence, right? Or it will not touch the meaning of the query. It will not touch the executional sequence, right? So it will just try to basically will try to play around the optimizations of joins, right? Let's say any join which could have been done, like let's say in our query pattern we have written at the later point, right? But what Hive thinks that if I do this join part even in the beginning phase and then flow that data, right, in the downstream part, doing all those aggregation which you have mentioned in the sub query or wherever in your main query, that would have been done easily, right? And similarly for the where clause, let's say you have written all those group bys and all those things, and at the end you are doing some kind of where, right, where clause. So what Hive thinks that why would I even wait for my query to get completed, process on huge number of data, and then apply the where clause? Hive is smart enough to sense that part. So that is why when it has created the plan, it has moved that where clause by default to the initial part where the data can be filtered and data size can be reduced. So the semantics or the meaning you have written for any of the query, that will not get changed. Hive will internally will create multiple DAGs, multiple permutation combinations of the execution plan, and then it will figure out without touching the meaning, without touching the meaning of any query and the output of any query, what is the actual cost will be related to each particular query plan, and based on that it will try to ignore others, right? So that's how it will be working, right? Your query meaning will not be changing ever, right?
So does it mean like if I'm writing a query to do something, so Hive internally is looking for a better approach or like that, or like uh, because if I'm typing anything and like as you said, it is like looking for that subquery part you mentioned.
Mm-hmm,
So what I'm not understanding is like obviously if I'm typing select all from employee where location India group by department, I will get one output. And
mm-hmm,
if I type select all from employee group by department where location from India, I will get a different output. So two
mm-hmm.
outputs are different. So in this case, Hive is internally determining that is it trying any combinations in its own, or like how, like
Yeah,
that's
it
what
will try, right? It will try from the optimizations perspective, right? That is when I'm trying to make you understand, right? Whatever best it can do in order to reduce the size of processing data, right? And all these things. So, I mean, that's how it will be working. I mean, I haven't seen anything where the query plan, let's say you written some query to get the output and Hive changed it internally and generating different output. It will try its level best to sequence, like to put the executional steps in such sequence so that minimum processing time like is taken by the query and in terms of the amount of the data which is getting processed. So that's how it will be.
okay. And related to the practicals, like today we were doing following whatever you were saying. So right now I am practicing on my laptop. So that
Mhm,
is like a single, like my node, like just one system. So I
mhm,
was just curious to know, like if we are having a node of like 100 or maybe just 10 different things, and
mhm.
if there are like different laptops are having like different part of data, so is it the same approach, or like we have to write different query, different lines, like create table from here, take data from this, and then join everything together? Like
No,
how
no. So
does it?
it will be like simply Hadoop cluster. Whenever, let's say, you will be having a Hadoop cluster and you will be accessing, or you will be actually on the name node, right? Which knows all the
Yes.
metadata and everything. So you will be creating a Hive session there, and from there you will be firing a query, right? So all this detail and definition, right, where my data is located, right, you don't need to do it separately. You are just using Hive just like a MySQL, where, right, you can use these commands, show table, show databases. You can get the table names, and after that you just work on it simple, just like you work on the SQL. And after that everything will be taken care by the engine itself. Like even one data set, it was divided in 5 parts or 10, 20, 50 parts, doesn't matter, wherever those parts are located across the network, it's responsibility of the engine to bring them together and complete your operations, but you don't need to worry about it.
Okay, and like one last doubt, when you were talking about the loading data right from the SDFS part, so like first you took the temp so that there is no permission thing, you loaded data there, you
Mhm.
copied the same data from the local the Cloudera thing to Hadoop, And then there was one point where you were giving the path and you were not mentioning the data, that CSV data thing, because you said that data is already there.
Mhm.
So at that situation, is it possible that two different datas can be there in that place, and then Hive can, like, how will Hive, because that in the
Yeah,
lecture.
I get your point. So your
Yeah.
point is like the directory within that one file was department underscore data dot CSV.
Yes.
Let's say what happens
Yes.
if I put employee underscore data dot CSV, it will
Yes.
have
Yes.
different
Correct.
columns and all. So see, in that case, the schema you have created, right? That is something which you created by considering the department data.csv, and now you are putting any other data set, right, which is not matching with your schema and all. That is something like garbage in garbage out. So in that case, what will happen, your queries will start getting failed or whatever. Let's say you have created external table, right? So you won't be even able to execute your queries because data is something which is garbage data, like mix of multiple things, right? Even I will not be able to identify that how to even read it properly, because it will always try to do that part, read, like it will try to complete this thing, um, schema on read. So first you created that table part definition, then you are trying to read it. So that validation will start getting failed because there was mix of data, right, which is not getting
Okay.
matched with this schema. So those things, it will be failed. So the way things work in the production and companies, right? So the way have created directly, let's say we have one data set which is for the payments data. On daily basis we will be getting the payments data, so we will have a dedicated directory to it. And uh, we are not intended to write any garbage thing or any irrelevant data set into that directory, else obviously things will break. That is the practice which is being followed on the systems, right? So you need to write, or you need to set up your systems in such a way that those things are getting prevented, right? Nothing is
Right,
writing
right. So
garbage
that is
data
a
in your directory.
best practice you're mentioning, that
Yes,
whatever data is there, have that thing.
correct.
And today you have, like, it was very nice of you that you were copy pasting in the GitHub thing. But like one small request, there is like one command where you can get all the history, right, of all the things what today
No,
you have typed.
I know,
Is it
I can do it. But the point is, right? So I want you guys to do it hand to hand. Let's say I
okay?
have
Understood.
completed
Yeah, yeah,
five,
it's
10
fine.
steps, and then I'm like putting it in the GitHub. So you need to wait till that long, right? That is why whatever else I'm executing 2, 3 steps, I'm just pasting in the GitHub so
Waiting,
that
right?
quickly you
Okay.
guys can also practice it. That's it.
Okay. Sure, sure. And this mapper and reducer, when you were running, right, you were showing it in your system that mapper 0, reducer 0. But when I was running in my system, I was immediately getting the output. I was not seeing any mapper reducer. Is it fine, or like,
Yeah,
like
it is also fine, not an issue. Means that's not an issue, because
fine, right?
here what I'm not using the Cloudera environment, Cloudera as in like the VM and all, because I'm working on the lab environment. So like from the next week you guys also will start getting the accesses for the lab environment. So you will see little bit different behavior, but that's completely fine, not anything
Okay.
like you need to concern on that part.
Thank you, Shashank, and happy Teachers Day, and
Yeah,
congrats for your 1 lakh subscriber. Thank you. Thanks.
thank you so much. Moving on to next, Abhishek.
Hi, Shashank.
Hey.
I have a few questions actually. Like whenever we move data from SDFS or local, so
Mhm.
how does the replication factor is managed?
So, okay, your point is how to, like, that replication and all these things will be managed, right?
Managed.
So that is something, the default configuration, right? For every file, right? Let's
Hmm.
say you have 10 files and you
Hmm.
want to copy it into 10 HDFS location, and for
Yeah.
each file you want to achieve the different replication, right?
For example,
So
three.
that, yeah, that is not achievable. So it
Hmm.
will be generic and it will be configurable. So whenever you set up your Hadoop,
Hmm.
so during that time, there will be configuration files where you need to mention the replication factor, and
Yeah.
that will be generic for everything.
सो शशांक फॉर एग्जांपल जैसे कि मेरे पास एक एसडीएफएस में मेरे पास एक फाइल थी, जैसे कि हम जो डेटा सेट था हमारे पास, और उसको हम लोगों ने जैसे ही मूव किया तो वो कंप्लीटली एसडीएफएस से वाइप होके आपके हाइव के वेयर हाउस में चले गया, जो
Warehouse,
जो कि
correct.
एसडीएफएस ही है. सो इन दैट केस आपका रेप्लिकेशन फिर वो कैसे उसको वो कर रहा है, चेंज कर रहा है. फॉर एग्जांपल उसको मेटा
So,
डेटा में तो वो
yeah, I
अपडेट करना
get your
होगा.
point. So see, even my Hive is using the same HDFS and Hadoop environment, right,
Yeah.
as a warehouse. So that
Hmm.
is why the replication factor will be same as it was for the like inbuilt installed HDFS we have in system. Let's say you have one HDFS as a source wherever you are putting a data, and your
Yeah.
Hive is installed on somewhere or anything like that.
Data
You
nodes.
are using, yes, you are using your own HDFS with different configuration, so the
Yeah.
replication will be working accordingly. But here my source HDFS was same, and I have just assigned one corner right for the Hive warehouse in the same HDFS, so the replication factor was also common.
सो बट इन केस जैसे कि हमारे पास मल्टी नोड क्लस्टर है, तो ये कहीं ना कहीं जाके अपडेट होता होगा तुरंत, राइट?
हाँ,
इन
so
केस हम लोग अगर मूव कर रहे हैं.
right, yeah, so this HDFS part is the part of Hadoop whole environment, right? So that thing will be taken care by the name node itself, because before, without even setting up that cluster, your HDFS will not be up, your yarn part and all those things will not be up, right? So that will be taken care of by the name node itself, updating metadata, replications and all.
Okay. एंड शशांक एक स्टोरेज से रिलेटेड डाउट था मेरा, जैसे कि फॉर एग्जांपल हम मान के चलते हैं कि मेरे पास एक 1 GB की फाइल है, और मेरे को उसको मेरे पास जो ब्लॉक साइज है मेरा 128 MB है, एंड मैं उसको 6 डेटा नोड्स में स्प्लिट कर रहा हूँ. सो हाउ मच डेटा इट विल टेक, लाइक फॉर एग्जांपल मैं उसको डायरेक्ट हाइव के वेयर हाउस में डाल रहा हूँ, लोड कर रहा हूँ इंटरनल टेबल में, सो इट विल टेक 128 MB और 256 MB.
Yeah, so whatever, like, see, here everything, whatever has been configured, so whatever default, let's say in the Hadoop 3.x, right, version we are using, so it will be 128 MB, right? And before versions, let's say Hadoop 2.x, 1.x, it would have been the 64 MB. And again, these things are configurable, right? Right, whatever configuration you have used while installing the Hadoop, so the block size and even replication, everything will be working in the same fashion, right? Nothing is something which you can configure on the runtime that for this file use this number of block size, for this file use this number of block size, because that is something which cannot be generalized by the name node.
एंड लास्ट क्वेश्चन शशांक ये था कि फॉर एग्जांपल कल आपने बोला था कि जो हमारा हाइव है ये आपका स्कीमा ऑन रीड है, बट जो इंटरनल टेबल्स का कॉन्सेप्ट है उससे तो फिर ये ऐसा हो जा रहा है ना कि स्कीमा ऑन राइट भी हो सकता है, बिकॉज वी आर फर्स्ट हम स्कीमा क्रिएट कर रहे हैं फिर हम राइट कर रहे हैं डेटा, सो इट कैन बी बोथ.
राइट, सो आपका भी वहां पे सी पॉइंट, यहाँ पे क्या होता है जब हम लोड करते हैं ना, सो आपने वहां पे देखा होगा कि लोड करने के बाद वेयर हाउस में एक तरीके से डेटा पहुंच जाता है वो. ऐसा नहीं हुआ है कि जैसे माई एसक्यूएल की हम बात करें, टेबल बन गया फिर रिकॉर्ड बाय रिकॉर्ड उसमें इंसर्ट करते हैं, राइट? Sorry for like other peoples are also there, so I started speaking in Hindi. So right there will be like multiple insert statements which we keep on inserting and which we keep on executing, so row by row objects will get into the physical memory locations, right? So in Hive, how it is happening, if you remember, right, if you can replay the recordings, right? So as soon as I did that load part, right, load from local to my table instantly, right, within just fraction of seconds, right? Because it was a small data, even let's say GBs of data, it will just take like a few seconds and minutes to get completed. So I showed that location where my warehouse was created, and within the table name one file got created, something depart underscore data dot csv. So even for the load command, right, what actually happened, load was something moving data from somewhere to my warehouse HDFS, and on top of that, when I'm firing my query, then that schema on read is getting applicable there. That's how it is working.
A bit confusing, but I guess मेरे को थोड़ा और ये देखना पड़ेगा, थोड़ा confusing है शशांक ये वाला part.
Right. So again, simpler word. So see, in MySQL, right, as soon as you create that table, right, then you apply, let's say, not null part, the integrity constraint, and then you prepare your insert command, and you provide some values, and as soon as you fire it, right, what will happen instantly? What will happen? Things will break, because integrity constraint, let's say, is not getting matched, these kind of
Yeah.
things, right? So things are getting validated on the right time itself.
Yeah.
But in the schema, in this thing with the Hive, what is happening, although let's say we created an internal table, metadata and all these things happen, but validation is not gonna be happen during the load time, right? First time, let's say when we loaded the data, we use the table name, it just went to the warehouse part, right?
Okay.
And then when you started querying it, then you might be facing that, okay, we have copied the loaded the wrong data into it,
Okay. Okay. So okay, ठीक है, अभी समझा थोड़ा शशांक.
right? Yeah.
Yeah. Thank you, शशांक.
Cool. Next, Henry.
Hello.
Hey.
Okay. As of yesterday, when we discussed, I sent you the link and this thing. I've not gotten your response.
So, oh, did you say share that link on my ID? Because I remember even till yesterday night, I didn't see any mail from your side.
I did. I can even share my screen to show you how I sent it. I did.
I'm not sure again. I can quickly check my mailbox, but honestly, right, I checked it, right? What's your email ID, right? I can quickly again.
Chidi Henry 12.
Let me check it. On. No, man, I can see only 2 mails, like, and those were different queries. I'm not sure whether you use the correct email ID. Can you verify, did you send it on this one, shasgnk@neuron.ai?
It's not, I can't see your mail.
Yeah, I'm sharing. Did you use this one? Because if you would have
Yes.
sent, I have even checked the spam folder, but I can't see any mail.
I did.
Your name.
I did. I can share my screen and show you that I even send a supported message to you. Like I've shared
I tried it yesterday. I couldn't get a time to figure out, right, why that that option was not able. The screen sharing, right? I can probably, but again, it might take time to understand the whole problem statement, Henry. But it would be good, right, if you can send that link to me so that at least I can understand the problem statement. Now, right, my email box is open. Can you try to send reshare or forward that mail again to me, and we can quickly check it, right?
Okay, let me do it now while you're taking other
Yeah,
doubts.
other doubts. Yep. Next question from Anmol.
Hi Shashank. First of all, thanks for the wonderful session. I just want to ask, like, when I fire some select query with some aggregation function on my Hive, there is something called stages. So what are those stages and how these stages are calculated? Like, if I...
All right. Yeah. So see, if you want to understand this stages part in depth, right? So that will come in under the Spark part, right? Then you will be able to get the whole idea of stages, because that is something we will be covering from the Spark UI. So in the similar fashion, it works in Hive as well, but I can give you a very high level overview that what this stages means, right? So yesterday, if you remember, I have like I wrote couple of steps: filter, map, right, and then joins and group bys, right? So the concept of stage in distributed environment is, let's say there are 2-3 transformations which can be performed linearly without any data shuffle. Those will be a part of one stage. But whenever in your application you have used the kind of transformations or operations where data shuffling is required over the network, then there will be a new stage which will be created, right? So that is why the group by operation, the join operation, the reduce by key operation, these are the common examples of the transformation where shuffling is required, because let's say on a distributed environment, you want to perform a group by. So group by will be done on some keys. You will be using some attributes for it. So, and even for those keys, let's say few data is present on data node D1, a few section of that data related to key is present on data node D2. So everything needs to be come at one single place. Then that calculation will be done on the group by attributes. So that is the concept of stage. On a higher level overview, you can understand. But when we will be discussing things in the Spark, right, this will be pretty much clear to you, because I will make sure you understand it from the practical Spark UI. I will show that thing on the Spark UI, that how and where this stage is getting changed.
In one stage, there are multiple tasks, I can say.
Yeah. In one, yes, in one stage, there will be multiple tasks. Correct. That is true.
Okay. And next thing, Shashank, I won't be able to create table in my Hive environment on my laptop. It is taking a lot of time. So
Okay.
when
Yeah,
will
let's
be?
wait for, yeah, let's wait for tomorrow time, and probably by this week itself, right, you will get the communication for the lab environment. So I guess till then, whatever like you can do and whatever you can understand from these sessions, just keep on revising it, and once the lab environment is up, then you can practice it.
Fine, fine, fine. I can practice on my company's EMR.
Oh yeah, that is also fine, right? Just the test tables and all that would be good.
Okay, okay. Thank you, Shashank.
All right. Next question from Sahil.
Hello.
Hey Sahil.
Hello. My doubt is related to data node and this main node.
Mhm.
Usually we have only one here, one system.
Mhm.
So when we set repetition factor 3, so in
Mhm.
such cases, what will happen? So in single machine, 3 copies will be created, or this will generate some kind of error or something.
So you are saying you have only one data node, is it?
Yes, right now I have only one data node. So
Yeah, so
how?
in one data node, right, so things will exactly work in the same way, right? Three replications, maybe three segments of it will be created, right? Let's say one segment got crashed, so the another one can be stored, because it, even in your external disk, this could be stored in a different virtual memory space, right? So that's how it will be. But replication is something which we never talk about when we have just one node or something, because we are not leveraging replication in a correct way if we have just one single machine. Replication will be helpful when you have your data nodes distributed over the network, and even the rack awareness concept is also involved there, so that even one whole segment of one data center goes down, still you are able to get your data and it is not getting lost, right? But if you talk about the one single node, virtual memory spaces, three segments will be created, whatever replication factor you have given. But if your entire machine goes down, even your replication factors won't be able to save you.
Correct. And there is a one request. So during first 10 minutes, we are like just idle. So is it possible you to share some your experience or stories as you are an experienced person?
Okay, yeah, that's a good idea. Cool. But so starting 10 minutes, most of people like just keep on joining. So I'm not sure, maybe only 50, 60 people will be listening to my story. But I will try, right? I will try to engage you, right? Maybe anything, my experience, interview, company, bad experience, good experience. I will utilize those 10 minutes as well. Thanks for the suggestion.
Okay. They could watch recordings actually.
Yeah, that is also good. Correct.
Okay. Thank you for a
Right.
wonderful lecture.
Thank you. Next from Venkat.
Hi, Shashank.
Hey.
Sir, the thing is, I'm totally struck where means like you said like to upload the file right through FileZilla or something. So I totally misunderstood that, and I am not aware of doing the thing.
No,
Could you
no.
please
Can
let
you
me?
repeat?
Yeah, basically you have downloaded the CSV and you have uploaded it into Cloudera, right? Like you asked us to download, or you asked us to save the file in Notepad++ in our local computer and transfer to FileZilla.
FileZilla. From
yeah,
FileZilla to the Cloudera VM.
Cloudera. Could you please show it to me? And also after that you created the temp, right? There I got stuck and I didn't process in my laptop.
So that time, right, that time I asked you, right, to try both of the things, because see, I was on the lab environment and also I am using Mac, so won't be even able to like show you things from the FileZilla, right? That is why I said, even if you feel, if you are facing any challenges, let's say for transferring FileZilla to Cloudera VM and all, so you can reach out to the tech support team. They will solve it for you on a live session itself, right? But the thing or the main purpose to use that temp part was because since this lab environment is completely new, right? Just 1 or 2 days back, it got it was available for us, correct? So things related to the accesses and other things are still pending and team is working on it. So that is why when I was trying my hands like with the external tables and all these things, so when I copied data in my home directory, so I was getting some permission related things. I tried to fix it, but still there was something which was missing. So that is why I used a system's temp location. So temp location is always meant for temporary task, right? You won't be like finding any permission related issues and other things, right? So how, let's say for you, what I was actually trying to say, that how you should copy this data, right? If you have got confused on that part, I can quickly clarify that where first you should try. And for that one, let me share my screen quickly. Let me know if it is visible, right? So what I told you in your local laptop, let's say, right? So here from the notepad, you saved this file, right? Let's say data.csv. And this is in your laptop, correct? Right? And after that, you will be having this FileZilla environment, right? And here is your Cloudera, right? And within this Cloudera, let's say there will be one home directory will be created. Let's say /home/Cloudera, right? You are able to see there, correct?
Yeah, I can see that.
Right. So now with the help of FileZilla, what you did, you first tried to, like, you copied this data here. So obviously now you will be able to see this data in this file path, correct? And after that, what you can do, whatever load command you written, right? So load, after that, first you can try to use this path itself if it is working for you, right? If it is giving some permission error, then like you can try the temp part. Else you can simply write this thing. Let's say file : / then home, after that Cloudera, right? And after that your file name, as simple as that, right? If this thing doesn't seem working, so the file is something which is already present in your local environment. What you can do, you can run a simple cp command, right? And again file : home, Cloudera, and this data.csv. And where we want to place it, we want to just give a space /temp, and make sure before that within a temp you have created one directory. For that I have already shown it to you that how to do that. So now once that is done, so what will happen, your data will be, let's say within the temp I already created a Hive class, right? So here you will find your data, right? And you can use this path in that load command simply, right? So that is how you can do it. Now understood?
If the permission is got denied, then I need to
yes then you need to try this temp thing.
Okay. And one more thing, Shashank sir, like in the map you mentioned the collections integer type as string, but there it's a integer, right? Age.
So for that one, right, the age part and even that thing, So map is something we mostly try to use with those data sets where, let's say, symmetric data type we want to use, like either you have to be everything into be integer or string. But in order to resolve this thing, right, even mostly we would avoid to work with this kind of data sets, right? What you say, the map and all, we will be using the SERDES, serialization and deserialization, right, where everything will get converted into its respective data type, right? So we will see it in the next week. But since you want this sort of live example that, let's say, mixed data types, so in the next week class, what I will do, I will create one more data file, and will add this kind of map attributes where integers and other values are there, and will try to show you that how those things can be separated out.
Okay, okay, sir. Thank you.
Yeah.
Thank you, sir.
So yeah, let me next unmute Eric. Eric was here. Hey Eric, I have unmuted you. Please go ahead.
Yeah, hello.
Hey.
Can you guys hear me?
Yeah, I can hear you.
Yeah. So I am pretty new to this class. I just enrolled yesterday.
Mm-hmm.
I live in the United States, and it looks like we have a big time interval. It's pretty much almost 2 a.m. and I feel like I'm definitely gonna miss most of your live classes because of the time difference.
Yeah.
I pretty much joined this class because I'm in a PhD program, data science program, and very new to the program. And this semester, our professor gonna teach us big data analytics.
Okay.
But it's a new program, and it's a new course they mounted this semester. So it's gonna be a little bit challenge in the program for this semester. But it looks like you have experience in this big data stuff. So that's why I decided to enroll for this class, so I could get a backup from your teaching to be able to surface what I'll be learning in my school.
Yes, yes.
I don't know how I could be able to get much of the information from you, especially I'm probably gonna be using the videos that you may be teaching over time. And when I have a doubt, I don't know how to arrange to have a chat with you to be able to clear my doubts, because I would definitely miss your live classes due to the time differences.
Yeah. So for this one, yeah, I mean, at least for the, yeah, because of the time zone difference, whatever, let's say we start by 10 a.m. at least the IST time. So whatever time is possible for you to spend with us, feel free to do it, but don't stretch too much on that, right? Every weekend, 3 a.m., 4 a.m. From the health perspective as well, right? So don't do it. And recordings, everything will be available in the dashboard, right? Where you would have got the access. Recordings, whatever we are doing will be there. Assignments, doubt clearing projects, you will keep on getting. And for the doubts part, right? So you want to have you want to interact with me. So what you can do, you can keep on sending your doubts over the mail, and let's say something you want to have a discussion face to face, probably we can even when you are live at your own time, we can connect over the Google Meet itself, and just yeah.
Do you have WhatsApp for easy testing?
That is something we are not entertaining at this moment, because then I have to share it with everyone, right, to resolve the doubts personally, and that is why I spend 2-3 hours dedicatedly in each session to clear the doubts, right? But yeah, for you this is like the time zone difference case. So what I am saying that you can keep on, let's say till 1 week you had collected all your doubts, let's say 10-15 doubts, right? You have just collected it, and in the document form you have sent it to me in the email, right? And I will provide my answer for it, right? So that's how it can be. And time to time probably we can get connected over the Google Meet itself for 15-20 minutes in order to resolve your doubts quickly on weekly basis. Hope that should be fine.
That makes sense. And then today as you were teaching, I definitely didn't get anything. But I realized that I was not seeing what you were typing. And you did mention it looks like you on a dashboard doing something. I could not really see anything at all. So I don't know whether there's a technical problem on my side, or it's just you were doing something and I didn't get what is going on.
So you were not able to see my screen, is it? Like
Yeah, so I kept messaging, putting on the chat box that I wasn't seeing what you're typing. I couldn't see
so
the data set. I could not see anything at all.
no, that could be then technical glitch from your end. I guess, guys, you were able to see everything, right, over the screen. I was kept on sharing my screen and was typing everything over the terminal, and even in the chat box, you can see Eric. So probably that could be a glitch at your end. Maybe just try to fix it one more time. The Zoom, try to update it, or maybe reinstall it because it is visible for others.
Yeah, because I've been using this Zoom with my professors here, and I don't think it should really come from my side. I think it's I don't know where the fault is coming from, but literally I could not really see anything at all, and I wasn't sure what is really going on. But I could see you teaching out there, and it looks like the other students were cooperating with you, but I was totally lost because I could not really visibly
No,
see it.
I can understand. No worries. At least recording will be there. So whatever you have missed, you can check it. But try once, right? What's wrong with the Zoom? Maybe test it out, and let's see from the next time.
Okay, then I have last thing to ask. I could see you kind of post some stuff on the charts. When it is recorded, I don't think I will have access to click on the link whilst I'm looking to
So
record
yeah,
it.
these links, the dashboard access you have got, right? There will be a one tab named as resources. So whatever I'm writing and the links, right? All things will be provided there, so you can access it from there.
Okay, then that makes sense. Yeah. I think pretty much that was my situation at the moment.
All right.
Thank you for the
Bye-bye.
clarification.
Thanks.
Yeah, you're welcome.
Yeah. Next question from Jay.
Yeah, hi. So I was just following that, creating that internal tables. Okay, basically we have created two internal tables very first, right? So one is from the local and one is then from the HDFS as well we have loaded. So, and we dropped that as well, both, right?
Yeah.
And that time I was checking and going to the particular warehouse location and I could see that, okay, that schema also, I mean, it is just getting lost. But for external table, so where I could see, where I can see that schema. So for external table.
So for external table as the schema, right? You can run that describe command, right? You will get the.
No, but no, I'm saying that in warehouse somewhere I should be able to see, right? I mean, where
that was the difference. So in the internal tables, whatever data was outside, you copied and you dumped it into the internal tables, and that is why internal table just flush that data to the warehouse. But in the external table, the concept is have the metadata in Hive and point your metadata or the table structure to the data which is residing outside. So there is no need to bring it into the warehouse.
Yeah, okay, so that the schema for external table somewhere will be in the Hive, right? Okay, but that I don't want to bother. I don't want to check it, right?
Yes.
Okay, that's clear then. Other doubts got from other peers, and thanks for that. Thanks, nothing else.
Cool. Next from hello. Yeah, next from Shyam.
You cannot get out of class.
Hey Eric, can you please?
Hello.
Yeah. Yes, Shyam, please go ahead.
Yes, sir. Actually, I have only one small doubt. When I running the queries, select ID name skills 0 as primary skills from employee, but I'm not getting the detailed output. I mean, जैसे आपका है ना कि इतना टाइम लिया इतने सेशंस एंड ऑल वो सब जो आ रहा है वो मेरे में तो कुछ नहीं आ रहा एक्चुअली.
So that is completely fine. Well, that's what I'm saying. Ki Cloudera, I'm using the lab environment proper because here things are set up in a not one single node, right? Because here everything is we have in the lab environment 7-8 nodes of cluster, right? So that will give you a complete distributed environment computation field. So in the you are using is basically the Cloudera environment, right? This VM in your machine. So sometimes those things will be missing from there, but when you will be practicing things on the where what you say the lab environment, you will get the same to same thing which I'm getting.
Oh, okay. I was so but that's why I'm not getting all the detailed things and
No worries.
okay. Thank you so much. Thank you, sir.
All right. Next from Nitesh, Sheshadri Nitesh. Hello, Nitesh. All right, so let's move on to the next. Venkat. Hello. Okay. Next one, Samreen.
Yeah, hi Shashank.
Hey.
Actually, I wanted to ask about the link you sent in the last message. Actually, I had lost network at that time. The Kaggle dataset link.
The Kaggle dataset. Let me
Yeah,
send.
why? What was the motive of it?
So that one, like, so whatever we have talked about, right? Loading data from here and there, creating tables and other things, right? So what I wanted that download this COVID-19 data set, right?
Okay.
And play around it, right? Whatever we tried,
Okay.
internal tables, external tables, and it would be much, much better by your business intuition, right? If you look at the COVID-19 data set, so as a data geek, what kind of let's say insights you can try to pull it out, because your tables will be ready now. It's just what kind of multiple queries you can fire, right? So that's what I want you to play around and write all those things in your documentation, that what kind of queries you fired and what kind of output you are getting and what was the business purpose to fire that query and the insight. So this would be the task, right? In terms of the things which we have done in 2 days.
Okay. Okay. And one more thing. I wanted to ask about the difference between insert and load. Is there a performance gap between the two? Is
Correct.
load faster or
So,
insert faster?
so insert will be faster in the transactional databases, right? So even there are 2, 3. I wanted to ask those things as a question from you side, but today I missed it and I forgot about it. But in the next class, I will definitely ask those things like the concept of the primary key in the Hive, why we have it, and if we don't have it, then what is the reason, and this even insert and load part. So to answer your thing, right, the insert and all these things will be faster, right, where we have the transactional databases, right, things works in the row columnar format. But whatever we have in the like the data warehousing services, right, and the file format, let's say Parquet, ORC, we will be using, those will be columnar data sets. And when we talk about the distributed computed and distributed storage environments, we don't talk about one single record, right, because data is in the terabytes and the petabytes. It is not like a typical transactional databases where your table is indexed and you can quickly point out to any particular record based on the primary key and you just went onto that location and updated it or inserted anything. So things don't work in that manner in the distributed environment. And the persistent storages like HDFS and S3, we are not supposed to just do an instant update on one single record or anything like that. Wherever there is a need, we need to create our warehouses in such a way so that we can do partition cleanup or bucket cleanup and then reinsert all those things in a bulk format, right? That is the reason we don't have these kind of like frequent, we don't use these kind of operations with these kind of warehousing services, right? Let's say the update or the insert for one single record, because in that case, what will happen, the Hive engine needs to scan that whole terabytes of data, petabytes of data stored in HDFS, and then try to find the location for the update or even to do that insert part, right? Which is something we are using the the Hive in a wrong way, because it is meant for the analytical queries. Just store the data and perform aggregations and all those kind of analytical queries, not this insert or these kind of CRUD operations.
Okay, okay. And one more thing, you mentioned about the external table that we have to create another directory and we have to point the create table statement to that directory. So can we do this like we can create the directory in the Hive warehouse itself, because at the end it is a directory only in HDFS. So we can create the in the Hive warehouse directory, we can create a directory for the external table there only, and we can point the external table to point to that directory in warehouse.
Yeah, you can do that.
In that case, would there be latency like you mentioned for the other directory? You mentioned that in external table we have some network latency. We have to pull the data.
In that case, it will not. In that case, there won't be those kind of issues. But yeah, that would be a one-time task probably for you, or you need to write. In that case, even like what will happen daily basis, you need to you should have a one automated job, because the data which you have pulled from the external to the internal warehouse, there should be one job every day. Whatever data, the delta data is getting copied there, right? You need to bring, you need to keep on dumping into the warehouse directory which you have created. So that will be extra overhead. But from your location, if that table is directly pointing to that one, right? So there is no need of separate job to sync the data, and that means you are balancing the time in that way.
Okay. Okay, fine. That's all. Thank you.
Yeah. Cool. So next question. Yep, Nitesh, please go ahead.
Hello, Shashank. Good afternoon.
Hey.
First of all, I would like to thank you. Today's class was awesome. I understood.
Thank
and
you.
there was some this thing like I couldn't follow a bit since I was working parallelly. So my main doubt is regarding the fields, like fields terminated when you had given, right? But when I had given field terminated, it didn't throw an error, but it went to the next line. So what I want to know is whether if I give field terminated also, will it work?
It shouldn't work, right? In my screen, if you remember, right, I was getting error because that was a semantic error, because it should follow the syntax properly. It will have fields, right? Not field.
Yeah, I got it. And another this thing, like in the temp this thing as you have created, right? The temp folder inside that we had created. So basically, whenever we are going inside the temp, it's in our Cloudera VM, right? If I'm correct. So from that only we will be loading it to HDFS, right?
Yes.
It's not in our local this thing, like local machine, right?
No. So once you have moved your data from your local laptop, right, to the Cloudera VM, now it has become a part of the Cloudera local environment, and from the Cloudera local environment you are moving things into the HDFS of which is already in your Cloudera VM.
Okay, Shank. So generally, whenever we are creating some folders, so it will be inside the Cloudera home/Cloudera, right?
Yes. So normally, yes, that will be your like sort of home locations, not the HDFS locations.
Okay, Shashank, sure. Thank you. So if there's any doubt, I will ask in next class.
Sure.
Happy Teachers Day.
Thank you so much. Next, Sid, SIDD, Sid.
Hello. Yeah, can you hear me?
Yes, I can.
Oh my God, I was too eager to talk to you for a long time. Okay, hello. Actually, my doubt is like, actually, as you said, like in case of internal tables, right? So that CSV file is directly moved to that table, right?
Yes.
But as soon as when we drop that table, it should get lost from both the places, right?
Both the places, as in, so it was vanished from the source location, right?
Source location.
It was vanished from the warehouse location.
करेक्ट बट फ्रॉम सोर्स आल्सो इट इज लाइक एज हमने वो मूव किया था राइट पहले, वो तो वहीं से भी जाना चाहिए.
we didn't move it, right? So when we were doing the load part, right? So load part, you have seen it, right? So
Yes.
so for the local load, it acted differently, right? I think the part you are talking about, when I use that local keyword, so the file was already present in my home location, and it also went into the warehouse itself based on the internal table. But when I was using the HDFS, right, the HDFS as my source location, so in that case, what actually happened, it actually moved, right? The moved happened. For the local one, the move will not actually happen at all.
यस इन केस ऑफ HDFS ओनली, बट जब जैसे हम ड्रॉप करेंगे तो वो वहीं से भी वैनिश हो जाएगा. वी विल लॉस्ट दैट डेटा, राइट?
That will move from the simply, yeah, that will move from the warehouse locations. But when you simply talk about the local, right, let's say file was in my /home/cloudera, right, local, and I am using that file in order to use in order to do the load part, load local in path something. So that is a different sort of behavioral, because where there it is a property of the local file system, not the HDFS, which is somehow getting used as a warehouse for the Hive as well, right? So that is as simple as for the local, like the way you made two copies, one copy you send to some other one, and the original copy is exactly intact at your home location. So
no, but in case of HDFS only, जैसे ही हम ड्रॉप करेंगे टेबल तो डेटा लॉस्ट होगा, बट एज वी सेड वी हैव 3 replicas, राइट? सो वो यूज में आना चाहिए ना?
नहीं, so that is why, मतलब हमने so see, in case of the external table, right, in case of the external tables, so source data will be remaining at the source, right? It will be completely intact.
It will be there only, yeah.
Yes. So in that case, when you have dropped, so that is what drop is something, right, which is not a command for the enjoyment. Anytime we can run the drop command, right? Drop is something which is very prohibited, right? When we talk about the productions environment, if you are a user of Hive, you are a user of MySQL databases, the admin will not even grant you the drop command execution, right? Permission for the grant command, revoke command. Those will be those are the operations which are very critical and should be taken care very carefully, right? Because randomly you cannot fire the drop command and erase everything from the warehouse and HDFS location. So that's how it is.
Means एक बार हमने ड्रॉप किया so वो 3 replicas भी नहीं रहेंगे
हमारे पास. Everything will be, yes, everything will be gone. No, like those replicas are actually for the failure and recovery. If system is getting failed by itself, right, or any machine failure, volatile failure, involatile failure, right, then in that case those replicas will be used by the system itself to recover itself. But as a human being, if we are doing it intentionally, then those things will not come into the picture.
करेक्ट इवन हम जो सिस्टम यूज कर रहे हैं क्लाउडेरा का, उसमें हमारे पास हाउ मेनी नोड्स वी हैव देयर?
So that is a simple virtual one. It's not like a distributed environment, right? It's a one single machine. So there one name node daemon service, one data node daemon service, right? These are running. You cannot completely replicate the whole, let's say 10-15 nodes of kind of scenario in one single machine. But the way it has set up, you can see individual services running in the backend. It will give you a feel of the cluster.
Okay, correct. Okay, thank you. Happy Teachers Day.
Thank you. Next, Mansi.
Hi, Shashank.
Hey.
I had a doubt regarding the entire working of HDFS along with MapReduce. So मैंने थोड़े बहुत ब्लॉग्स भी रीड किए एंड वीडियोस देखे, तो मुझे थोड़ा बहुत समझा है, लेकिन एक्चुअली MapReduce कैसे काम करता है डेटा नोड पे वो मुझे नहीं समझा. तो मुझे क्या समझा है मैं बताऊं क्या, एंड लाइक इफ आई एम रॉन्ग एनीवेयर देन यू जस्ट करेक्ट मी.
Yes, you can explain.
Yeah, so मैंने ये पढ़ा कि जो डेटा है वो पहले क्लाइंट नोड के पास आएगा, तो वो सबसे पहले नेम नोड को कांटेक्ट करेगा, एंड नेम नोड ही बताएगा कि कौन से लोकेशंस फ्री है, लाइक काइंड ऑफ एक आईपी एड्रेस प्रोवाइड करेगा डिपेंडिंग अपॉन द रेप्लिकेशन फैक्टर. सो जो डेटा है वो सपोज ब्लॉक्स में डिवाइड हो गए 128 MB, तो ब्लॉक 1 को अगर रेप्लिकेशन फैक्टर 3 है तो 3 IP नोड्स मिल जाएंगे, 3 IP एड्रेस मिल जाएगा, और क्लाइंट इटसेल्फ जाएगा वो IP एड्रेस पे एंड डेटा वहां पे स्टोर कर देगा डेटा नोड पे, एंड कंफर्मेशन मिलेगा डेटा नोड से वापस, एंड वही वो नेम नोड पे अपडेट हो जाएगा कि यहाँ पे डेटा सक्सेसफुली स्टोर्ड है। अभी मेरा डाउट ये है कि मैप रिड्यूस का जॉब एग्जैक्टली कैसे होता है, जिस नोड पे डेटा स्टोर हुआ है वहीं पे मैप रिड्यूस का जॉब लाइक एग्जीक्यूट होने वाला है, या वो कंटेनर्स एंड ऑल का जो फॉर्मेशन है वो थोड़ा कंफ्यूजिंग हो गया है?
Yes. So whatever data nodes you have, those will act like a worker for you. So the containers, right, which will be spawned, so those will be spawned on the data nodes itself. So वो काम वहीं पे ही होगा, जो एग्जीक्यूशन जो स्टोर भी हो रहा है डेटा, that will be also in the data nodes, and the containers which will be spawned for the execution, that will be also done on the data nodes itself.
ओके ओके, एंड ये जो मैंने अभी बोला कि जो IP एड्रेस नेम नोड के पास रहता है जो वो क्लाइंट को प्रोवाइड करता है, तो मैंने एक ब्लॉग में पढ़ा कि ये जो एड्रेस है वो उसको ये हार्ट बीट सिग्नल्स जो होते हैं उससे मिलता है, तो इज दिस करेक्ट?
Correct. So heartbeat, see, let's say in your cluster you have 100 nodes, okay, and because of any random scenarios, let's say 10 nodes are not working, right, not working at all, let's say the system crash or anything. So how your name node would be able to figure out that how many nodes are alive in your system, because those data nodes, right, could have stored the data for other blocks, and since those nodes are dead now, so name nodes need to take the decision to move data onto those nodes which are actually alive for the processing and execution. Okay, so for that one, every data node keep on sending a heartbeat signal to the name node in every 5-10 seconds, and based on those heartbeat signals, right, name node will be able to figure out that how many nodes are alive in the system and how many nodes have been crashed or the dead, and based on that statistics, the Hadoop admin team or the DevOps team can quickly look into the cluster and probably restart those data nodes.
ओके ओके, सो अगर कंटेनर्स जो फॉर्म हो रहे हैं प्रोसेसिंग के लिए वहां पे और डेटा किसी दूसरे नोड पे प्रेजेंट है, तो ऐसा भी कंडीशन रहेगा क्या?
Sorry, can you repeat this line?
लाइक प्रोसेसिंग के लिए फॉर एग्जांपल 2 डेटा नोड्स कंबाइन होके एक कंटेनर फॉर्म किए हैं, and
so one container will be spawned in one machine itself. It's not like container is even sliced into 2 data nodes. So container is like a simple virtual box have been created in one single machine, right, and within that execution is happening.
Okay, I got that. Thank you, Shashank.
Cool. Next from Dastagir, I hope I have pronounced your name correctly.
Yeah, can you hear me?
Yeah, I can.
Yeah, can you please explain like how can we access Metastore?
How can we access
Metastore?
Yeah, so Metastore, for that one, right, whatever, let's say wherever you have installed it, right, so how it will be done, right, I'll tell you. So if you want to get that complete feel that how to access the Metastore, correct, so for that, just start setting up Hive in your local system from the scratch. And yesterday I was explaining that you can use MySQL, right, as a complete external Metastore for yourself. So what you need to do, if you need to, or you want to get that entire feel, first you need to install the Hive, and along with that you need to install the MySQL instances as well. And in the Hive, there will be a one configuration file. It was like something site XML, something like that. Within that, there will be few tags created, and there will be one property where it will ask you to mention the location for the Metastore and the default DB which you are going to use to store all the metadata which will be generated by the Hive itself, right? So everything will be set up manually in that case. But when we talk about this Cloudera environment, right, or this lab sort of environments, these things will be pre-configured. We won't be having any kind of control and access on the let's say this part, the meta or the meta warehouse or the metadata access related part. You can only get this kind of access and feel if you have set up this kind of things by your own in your local machine, and you have that kind of admin access onto the meta stores which are getting used by these frameworks. So that's how it will be done.
Okay, thank you, sir. I have another question. Like this is regarding that external tables. So let's suppose we have a source. From there we are like we have pointed that source as like that source into an external table. Then we can do a select star, right? Then if in the same path, if we delete the old file and place a new file there, where will like the content will be different. If we do a select star on the external table, like the content will like it will fail,
So
it will give error or
your content will be new. So, but again, in that case, let's say earlier, the table, external table which you created, it was for, let's say, 4 column, 1, 2, 3, 4 column, you decided your schema and everything. Now, let's say you deleted that source file, original source file, you placed different source file and it had different columns as well, right? Random, anything. So obviously in that case, your query will not start getting executed because the schema and other things will not get matched. But let's say you are placing a new file, right, and it is following the same structure as previous, then your queries will execute seamlessly and you will be getting the new data. So whatever you have deleted so far or previously, right, that is something which you will not be getting as a query output because it is not available in the source location. Whatever will be available in the source location in terms of the external tables, only that data will be queried.
okay, sir. Thank you. And my last question is, how can we detect like name node is failed? Because if data node is failed, we can track it through heartbeat, right? So how can we know like how the system knows that we need to like get the FS image, the latest compiled FS image from like secondary name node to like
No, so
primary
you
name
can
node
see even if your
to
name, if your name node goes down and you haven't considered the high availability concept in your Hadoop cluster, right? So instantly everything will stop working, right? You will not even able to pay, you will not even able to let's say log in onto your Hadoop cluster, your yarn will not be working, right? So everything will go down. And so when we work with these kind of large clusters, right, in the production and company levels, we will have a dashboards, right? Dashboards of the different IP addresses. So that is how even when we have these kind of large scale systems, we set up the alerting and monitoring. So anything, anytime, any point of time, things goes down. So right, things like you will start getting the alerts, right? Dashboard is something which is capturing the logs in real time, and for next 5 seconds, 10 seconds, it is not receiving anything, right? It will raise an alarm, and admin team and the DevOps team will get a notification and they will quickly look into it, that what actually went wrong with the name node. So if we would have included the high availability concept, then we would have the standby name nodes as well in the picture. So this is the also concept of high availability in Hadoop cluster. So there are two things: secondary name node and standby name node. Secondary name node is only for the backup, but standby name node will actually is your up to dated name node, right, which is working in the active passive mode. So till the point your original name node is up, your standby name node will be in the ideal state, right? It is not executing, not doing anything. But as soon as your original name node goes down, if you have included these concept of having standby name node and all these things, that will come into the picture quickly, right? The standby name node. So that is how it will be achievable, and that is how things are done on the production level things, right? So I hope this is clear now.
Yes, sir. Thank you. Thank you so much.
Yeah. All right. So Abhishek. Next from Abhishek.
Hey, hi Shank.
Hello.
Shank, I have few questions around it. So one of my question is like I am in Mac M1 system. So first thing is like I have set up that Docker environment, but I actually am not able to push files from FileZilla as this is in Docker environment, isn't it? So what I've done, I've like
So you can you can mount the volumes.
How can I mount the volumes?
So so okay, have you been like read about this concept of mounting the Docker container environment with the local host folders? Have you gone through with it?
No.
If not, then yeah, I would say just give a read to this concept, like mounting the volumes in the Docker compose file. Then you will get the idea, right? Even in that case, you don't need to copy things from the local to the let's say container. If you want to do that, that is also doable. Let's say just log into your container CLI, right? And from there you can point to your file which is in the what you say the local system and copy it to the container. But that will be an iterative process, because every time you will restart your Docker compose file, new container will be creating. So every time manually you need to copy files, right? But if you want to do it in Docker compose, you can mount your volume. So whatever, let's say, virtual folder you have created in the Docker container, ultimately it will be pointing to some location in your local machine, right? So that's how it will be working. But I would say give a read about it, then you will get the answer of your question.
Okay, and the topic name is like mounting the files in Docker Compose, whatever.
So like the simple search will be mounting volumes in Docker, simple.
Okay, mounting volumes. Okay, sure.
All right.
Yeah. Apart from it, everything is done from my system. And I've like, even though I've like done the same exercise through the creating files in my temp directory via Vim, and then
Great.
read all the things.
Great.
Yeah, thank you.
Yeah. So guys, I'll spend next 5-10 minutes and ask your questions quickly. So next from Venkatesh.
Hi, Shashank.
Hey.
Yeah, hi, Haspa. Congrats for your 100K.
Thank you.
I'm all happy Teachers Day. I have simple doubt, okay? So basically we used to replicate 3 right by default in HDFS. So can we see the replication through terminal? I mean replicated data.
Replicated data, no, that is something, right, which is managed by the what do you say the name node itself, right? The replications is something you won't be able to get it, because for the user, it is simply like copying data to HDFS, and under the hood it is all daemon processes, backend processes, which are doing all these things and not exposing to the user. But since even I haven't tried it yet, but you can give a read about those FS image. Let's any way to read the FS image and to iterate over the FS image, because whatever name node is doing, it is putting everything right in the FS image. So any way to parse FS image and look into it and deep dive into it, how it will work, that can be explored as an option.
Okay, fine, I'll look at it. Thank you.
Yeah. Next from Narayan. Hello.
I am audible, sir.
Yep, I can.
सर मेरा ये डाउट था कि अपने लैब एनवायरनमेंट यूज किया और मेरे पास क्लाउड है तो हाउ टू यूज
So don't worry, that is matter of a week, right? So lab environment will be as well. till the time what is doable for you guys in the Cloudera environment, just keep on doing it. Else things will be rectified, right? In just 1 week, once that lab environment is available for you.
क्लाउडेरा पे प्रैक्टिस हो नहीं सकता सर अभी
Right, you can do it, right? So again, sometimes there could be some challenges, right? And because things are completely machine dependent as well, right? People have Windows, Macs, right? In few machines, even let's say configuration is not working properly, VM is completely down, so all those challenges will keep on coming. But the things which I talked about, that can definitely practice on the Hive, can be practiced on the Cloudera environment, because Hive is installed there. But if you are facing challenges in moving files from here and there, then probably you need to wait for the lab access. But if you are able to do that, then simply everything, whatever I have taught today, that can be practiced there, not an issue.
Sir, actually, I can start. I cannot start on Cloudera because when I मतलब कहाँ से start करना ये समझ नहीं आ रहा सर Cloudera पे.
So if you are new, maybe I'm not sure you have seen the initial classes, right, where all setup
नहीं सर मैंने किया है इनिशियल क्लास अटेंड किया है सब किया Cloudera फाइल जिला अपना पुटी कॉन्फ़िगरेशन सब किया है लेकिन आज जो आपने पढ़ा है वो कैसे स्टार्ट किया वो सब
so that is something, right? Simply I told you, just on the terminal type Hive, right? So Hive shell will be opened and other things, whatever I told you, just you need to replicate it. So probably what you can do, just again watch the recording one more time, right, and try to do it, maybe in your pace, pause the videos and all. But if still things are not working, then definitely in the next week you will have the lab environment, but still you want to use Cloudera, I will connect the technical team members who will sit with you to fix those things on your Cloudera.
ओके और एक डाउट सर था मेरा वो एवरो स्कीमा वो क्या होता है
Avro, so these are the file formats, right? Just for this one, understand, and you can read it again, type like Avro file format, Parquet file format, and Warsi file format. You will get a detail about it. But in a long story short, it is a file format. Like the way we have CSV file, we have JSON file, we have other files as well, like the Parquet, the ORC, and the Avro. So that is also one file format.
Okay, thank you, sir. Happy Teacher Day advance.
Thank you. Next, Kundan. Let's be quick, guys.
Yeah. Am I audible?
Yes, yes.
Am I audible?
Yes, yes, yes.
My question is regarding Hive warehouse. So Hive warehouse has been configured within SPFS as shown by you. So can it be configured somewhere?
No, so that is not configured. What's your question originally? Like you are saying the HDFS is something.
No. Hive warehouse means in which the table data is being stored. So can Hive warehouse can be within some other file system, like local
Yes,
file
it can be. Yes, it not local. It will be always the
AWS.
distributed and persistent file storage system, right? Not the local and other. Yes, it can be S3 as well.
Okay.
Yeah.
Thank you.
Yeah. Next, Ayushi. Hello.
Yeah. Hi, Shashank.
Hey.
So I just have a very small doubt. Actually, that external tables, right? Just like internal tables, we can see them in a particular location or warehouse, right? In Hive. So where we can see the external tables?
I think I
Is there
explained this answer a few minutes back. Somebody else also asked this question, right? Where the external table will be there. So external means external, right? You are not bringing anything into your system. So whatever you would have brought in your system, in your warehouse, that is why you are able to see it. But in the concept of external table, have schema in the Hive engine, but point your schema or like the table structure to the data which is stored outside or external, right? So in this case, what is happening? Your query is getting executed on top of that data, which is stored, right, on some external HDFS path, right? So in the case of external tables, you are not bringing data from this HDFS to your own warehouse. That is why in terms of the external tables, you don't see any entry in the warehouse. Only metadata will be maintained.
Okay, so unlike the data warehouses, we have, like in a database, we have different tables. We can see that,
Yes.
right?
So
But for external tables, it is not there,
yes,
right?
yes, exactly. Because your data was there. That is the creativity of having the external tables. Why to bring the data, right? If let's say you have a kind of database where you don't have the space, right? And just in simple example to understand, but you want to execute something, you can create a serverless environment just to compute the query. Just have the data on the storage location, create table here and fire the query. Simple.
Correct. Yeah. So we only maintain its metadata, that's all.
Metadata.
And it
Yes.
will going to extract the data from the HDFS location where CSV file is kept, right?
Yes, 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 exactly.
Okay, great. Just last question. Maybe this could be also repeated. I'm not sure, but uh, is that possible that in a HDFS location, right, temp location where we are keeping our CSV files, so is that possible we can keep multiple files in that location, and how external table will behave it at that moment?
Yeah,
If
that one I also answered, because if you are if you are putting garbage data, let's say you created your schema for something, right, different. Now in that directory, if you are putting any garbage data which you know that it will not match the schema of this external table, so obviously your queries will not get executed, right? Your query will not be able to read that data, because this is how it is not getting matched, correct?
Yeah,
So
yeah.
that
Sorry to cut you, Shashank, but I'm trying to question that what if I have 2 to 3 multiple CSV files with same number of columns?
yeah, same number of columns and it is following the same data, right?
Schema, yeah,
Then
yeah.
yes, then it will definitely read it, right? So that happens with the Parquet file format, right? Yesterday I was saying, right, multi-part output. So in the HDFS, if you are writing multi-part output, and tomorrow, like in the next class, I will show you these things. This is one of the topic which I will teach in the Hive class. Right, if we are storing data in different file formats in our warehouse, then how that multi-part data will look like. So when we actually work with Parquet kind of file formats, ORCs, right? So they write their data in the multi-part, right? That won't be in a simple one single Parquet file or something like that, right? So that is how. So if your data set is something which is following those number of what you say, the column and the data and everything, your
Structure,
queries
yeah.
will be running seamlessly.
And there could be the possibility of duplicates as well in such cases. If we have the multiple files, there could be the multiple records as well, right? So in our external table, we can see duplicates, right?
In the external table, duplicates as in when?
Like suppose we have 2 to 3 files,
Mhm.
same files with same structure, and from external table, if I'm trying to do the querying, so I
Mhm.
could get the duplicates, right?
If your data is duplicated in both then those files, then yes, you will get the duplicates.
Yeah, then we have to further add some of the
Yes,
filtrations to remove those.
yes,
Okay,
yes.
yeah, yeah, that's answered my question. Thank you so much, Shashank. Happy
Okay.
Teachers Day.
Thank you.
Yeah.
Next from Balram. So next I will stay here for 3:15, guys, and then we'll end up, and whatever we have probably we'll cover it in next.
Shashank, my question is answered. Actually, it was regarding, I mean, external and internal tables, but I think it is clear because as we just need to create the schema, as I
Yes.
have understood, whether it is internal or external table,
Yes.
right?
Yes.
And at the time of reading, it fetches the data and shows us, right?
Yes. Yes.
So it's clear to me. But can you tell me one more thing? about the location, because you were mentioning your location as temp slash something. So how it was decided that it is temp location
No,
for
that is
for
no,
your
that is
SDFS?
something. Yeah, that is something for us, right? It's up to you where you are putting your data in the HDFS, right? I choose temp. I could have created anything else as well if I don't have any permission related issues and all, right? I can do it. It's not necessary to create everything in temp.
But can we decide where we can place in SDFS, where we can place files in SDFS?
Yeah, that you can decide. I mean, it's up to you. Just create the directory there, right? You use the Hadoop FS and the slash like root, fire the Hadoop FS-ls command on root. You will see if any directories are created. If not, then create directory there and just use that one for your data storage.
Okay, okay. Yeah, no problem. All answer. Thanks.
Cool. Next question from Ashok. Hello, Ashok. Please go ahead.
Yeah, in what scenario do we create internal tables and external tables? Like any security constraint is there here, or when we move to cloud, like do we move external tables or internal tables? How is it? It is related to that, or
So see, here we have talked about the advantages, disadvantages for both of the thing. Internal tables, right? You know that if data has been moved and right, if you drop something, data will be lost. But your data is something critical, and you don't want the different systems, right, to move and shift data, and you don't want to take that burden, or you don't want to set up those pipelines, which is moving your data from some location to Hive warehouse, right? Then in that case, external table is something which is pretty much referred, right, or recommended as well, right, in order to use it. So that is the typical difference, right, and that is something which will help folks to decide whether to go ahead with the internal tables and the external tables.
so in real time, do we use like both the tables, like internal and external?
Yes, both, right? Even I remember my Amazon experience, right? So here, Amazon, we were using AWS Redshift as our warehouse service. So AWS Redshift also have a concept of internal and external tables, correct? So wherever we had a need, we wanted to bring something into the system, right? We were creating internal tables. If not, we were simply creating a schema in the Redshift, and we were pointing our schema to S3 location where data was sitting ideal, or a cold data simply. We don't want to touch it. We don't want to move it. We just want to query it. So that's how it was done.
So my last question is like, if you want to create an external table from Hive, like from Hadoop, so we can give the S3 location path of Amazon.
Yes, we can. We can.
Okay, that's it. Happy Teachers Day, Shashank.
Thank you.
Yeah.
Next, Deepak. Please go ahead quickly.
Hi, Sasank. Am I audible?
Yes.
Yeah, Sasank. So quickly, I will ask my question. So yesterday, so you were discussing related to that map reduce task, how we are performing while running queries. So the thing is, like, let's suppose I am running executing on the 10 TB file. So by default, it will be creating the reducers. Let's suppose 2 reducers got created. So I saw that the execution was very slow. So if I increase the number of reducers to 4 or 6, and it ran faster, right?
Yes.
So is there any such type of calculations, like how much reducers I can give so that it will execute faster?
Yes, I mean that can be analyzed. So first, like the standard numbers can be follow, at least like having 5 to 10, but eventually, right, based on the number of tasks, right? So when like you will be able to see the yarn, right, or like how your job is getting executed over the cluster, the number of tasks has been created, right, the number of map jobs have been created. So in that ratio, and also the amount of data you are actually processing, all those factors will be involved in order to figure out that what would be the decent number to use in terms of the reducers for our job, right? So that is something which comes under the optimization part as well, right? Let's say you started with the 5 reducers or something, and your data volume was only 10-15 GB, but suddenly you have started seeing the huge spike, right, or volume coming 50-60 GB, and it will definitely eventually take time, right? So in that case, you can have this parameter as well, right, to increase number of reducers, right? So that's how it will be done.
So
Means
it is like a hit and trial method, like that means
yeah,
like I have to
not
increase
exactly,
slowly.
not blind hit and trial, but some analysis as well, the ratios of the mapper task or the data it is coming, and something can be watched out for the dynamic configuration property as well, right? Dynamically deciding the reducer, number of reducer, right, based on the data or whatever is the load at that moment on the cluster.
Okay, got it. And next question is like I want to know the difference. Like, is there any such scenario like I created the same table in Oracle and Hive? So, is there any such scenario like means in respect to the querying? I did some query. So, is there any such scenario that Oracle give the faster result than the Hive, where Hive will be slower? So, is there any such type of scenario, or Hive will always give the quicker result than the
So
traditional
not
database?
not not quicker, because again it's a warehousing service, not a sort of transactional databases kind of thing, right? Because transactional databases have all those optimization in place, the indexing part, right? The concept of primary keys, fast access, fast filtration, right? So this is something which is made for the warehousing cold data and working on the slow uh, kind of storage systems as well, right? So Hive is something which will always take longer time. If also there are optimization techniques like partitioning, bucketing, using optimized joins, but still, when it comes to the very huge volume of the data, so first thing, traditional databases won't be able to handle it. But in terms of the Hive and all, yes, this is something which will take time.
Yeah, and the next question is like if we have the data lesser than the 128 MB, so is that Hive is able to execute that, and means like
Yeah,
regarding
it will.
performance,
It
or
will it will able to execute it.
okay. So so my next question is like regarding the difference between the internal and external tables, as you discussed. So one difference you told, like so if you use the internal table, the shuffling will be less, and the external table shuffling will be more. So can you explain me how that is
So
possible?
shuffling, as in, I mean, let's say you are just executing the data. So engine is like Hive is something which will be installed uh, like somewhere, right? So if even it want to process the data and query the data, so eventually it will go to the engine itself, where the Hive engine is installed for the processing part, parsing and all, right? So data will move for the processing. It will not move for permanently, but for the processing perspective and computation perspective, it will move. So that's how there will be a movement over the network. But when it comes to the localized, you can say Hive warehouse, so Hive eventually knows where it has like stored the data, or the where the data is stored in the warehouse, how to quickly get its metadata and parse it. So in that terms, right, it will be pretty little bit faster on the external table computation side when it comes to the internal one.
Okay, because I had this doubt because the user Hive warehouse and the location which we are giving for the external table, so
Right.
both are on the SDFS path only, right?
Yeah, so
So
because we are using this sort of setup, so generally, right, even in the production sort of environments, this would be the practice. I mean, if companies are using HDFS as their persistent storage, so their Hive and this kind of the environment we are using right now, right? So that is will be the same replicated by the companies, so that it shouldn't be like that my Hive is somewhere, my other Hadoop cluster is somewhere. They try to put it things together at one place.
okay, okay. And so next question is like so what is the meaning of the edge node? Means like I have heard there is like edge node we are connecting, means we
So
are
edge
placing the
node,
files in edge node.
so edge node is something, right? Let's say you have a Hadoop cluster or something. So directly you are not signing up onto or not doing a login onto the name node. Edge node is a side or connector node, right? Which will help you to act like a client. Just log in there and from there you don't need to do multiple SSH, right, or the security logins and all. And from there, that edge node, all your Hadoop cluster connectivity will already be configured and set up, and you can use that edge node as a client to fire and execute your queries and commands and Hadoop jobs, Hive jobs.
Okay, means when we connect to the PuTTY, we provide the host name, then we will be connected to the edge node only,
yes,
not
yes.
directly to name node.
Name node, yes, yes, yes.
Okay. And so my next question is like,
Can
so
we move on to next, folks? Deepak, like I think
yeah,
questions
one more
were
question,
already
only
asked.
one last question. So like we are running the Hive jobs, by default it is running with the map reduce. Okay, so so we can also set it up to run with the Spark also, like Hive execution engine equals to Spark. So what will be the difference? Means like running in the Spark submit command and running in the Spark as an execution engine. So what will be the difference?
So that we will cover in Spark classes.
Okay, okay, sure. Thank you.
Yeah. Next, K. Lakshmipati.
Good afternoon, Sashank. Hope this session was good. My question, not my question. Actually, I'm not getting the result properly. What is the result? What I'm getting if I querying, if I use select, it is showing the employee ID null as well as department ID and salary column as a null. Is there any problem with my CSV file?
So yes, might be, right. So have you stored it correctly and you are pointing to the right data, right? Everything.
Actually, I'm getting the string data. I'm getting properly the that name. I'm sorry, the department name. I'm getting administration, marketing, and I'm getting some department IDs also. But I'm not getting the complete uh, employee ID column. I'm getting complete null as well as the salary also. I'm getting the completely null.
So yeah, might be like so something like maybe during the copy paste you might have entered like one more extra, let's say new line columns or something like that, or maybe while defining the delimiters or something could have gone wrong, but eventually it shouldn't happen. So what you can do, probably try it one more time, right? Use those things and define the schema correctly, the data type and all, right? So whatever I have pasted in the GitHub, so please use those script again and try to execute it carefully.
Okay. Thank you, Sashank, and happy Teachers' Day on behalf of me. Thank you. It's a good class today. Okay.
Thank you.
Okay, thank you.
Next from V. Kyaja. Hello, can you please go ahead quickly?
Can you hear me, Shishan?
Yes, I can.
So I have three doubts regarding the first one is external table. Suppose we have stored the data in S3 bucket and we have been established a connection between S3 to HDFs and the metadata stored in HDFs, right? So if my data has been changed, I have added, like, let's say I have 10 columns in my data. So now I just added one more column. But how my metadata will get affected in HDFs?
Yeah, so in that case, right, it should definitely, you need to alter your table as well in order to accommodate that new column, correct? So because if you are not doing it, so schema and those kind of validations will be done on the read time itself, right? So the mismatch will happen and like queries won't get executed, right?
Okay, so you want me to alter?
Alter, yes.
And one more question, like suppose if you are filing a query on top of the Hive, so if I'm running the same query again, do you have any cache option in a Hive system?
So as far as I know, Hive don't cache right these things the way the other let's say NoSQL databases and other high performing data warehousing services like Redshift work. So Hive don't have that capability actually.
Okay. And one last question. So suppose if you are doing the loading the data from local to HDFS and HDFS on top of it, we are loading the data into Hive table, right?
So when you are taking the array data to Hive table, will that be only the ending point, or else directly once you load into Hive, or you do the mapping transformations and load into any data lake?
No, I didn't get this point. I mean,
so we are loading the data from local to HDFS.
Right.
HDFS as a CSV format. On top of that, we are loading to Hive table, right? So when you are loading the Hive table, so is that is the only the endpoint, or also do you have any loading into some different data warehouse?
So it will be stored in the warehouse which we have decided for the Hive, right? It won't be, let's say, getting duplicated to somewhere else as well. The warehouse you have decided for the Hive, it will go directly there in case of the internal tables.
Okay. But one last question, so don't mind. If you load the data into Hive table, will that be create a replicas in HDFS automatically? Do I need to?
Yes, it will. So whatever replication factor you have decided for the HDFS while setting it up, right? That will be applicable on that one as well.
Okay, yeah, that's it. Yeah, thank you, Shashank. Have a great day.
Thanks. Next, from the Etisham.
Sir, yeah, thank you. Sir, I just want to know about the truncate part. I didn't get that. What is the difference between drop and truncate?
So truncate, right? So yeah, when I did that part, right? When I dropped the table, and after that, what I did, I ran the select command, select star from table. So that time you saw, right? I was getting table not found error.
Yeah.
Right?
Remember.
So why that error was coming out? Because there were two things, metadata and the original data, right, which we store. So when we run the drop command, so metadata also gets erased from the backend databases, right? And even the original data will also get erased. But in case of the truncate, it will not clean, or it will not remove the structure or schema of the table from the backend databases. It will only do a cleanup for the original data part. So that's the main difference.
Okay. So schema means it is that syntax, right? Row. We
Schema,
have
like
employee
whatever, like
ID.
the number of columns and the table structure we have decided for it.
Like employee ID, employee name,
Yes.
like
That is schema.
but whatever inside that schema, only that will be deleted in terms of truncate.
Yes.
Right.
Yes.
Okay. And is there any place or a blog where I can learn SQL? Can you suggest?
So we will be having those classes, right? So meanwhile, you can prefer anything. If you find any good YouTube video or any link, right, where the topics are there, you can prefer it. Else we will be having right those things.
Okay, sir. Thank you so much.
Thank
Bye.
you. All right, so I think we are already 3:30. Now it's time to end the class, guys. So we will move, we will meet on the next one, and our agenda will be pretty much advanced and extensive. So make sure whatever we have covered so far, just do a revision for it, so that you are coming with a fresh mind, fresh energy, without having these kind of minor doubts, so that we can dedicatedly focus our energy to learn more about those advanced concepts. Because the number of times we will reiterate on previous topics, that will kill our time as well, right, in order to move ahead, move fast, right? So please, in the next one, I will be pretty much focused on at least in the starting 3.5 hours. Maybe I will avoid picking up any question in between the time I'm explaining, and anything I will try to avoid which is now related to the previous class, right? Because that's how we will be able to make it more productive. If we have the doubts related to the current topics, not again and again the minor doubts which we have, let's say, already discussed in this session. So utilize these recordings, right? At least the doubt session part is something which could be helpful for everyone, and whatever we have taught so far. So next week we will be focusing on that part. So till then, thank you so much. Thanks for joining. Bye bye. I'll see you next week, and enjoy your rest of the day. Enjoy the match as well. Bye bye, guys.
Bye bye.